Picture this: a swirling cosmic masterpiece, two galaxies entwined in a dance that's lasted millions of years. This isn't just any corner of the universe. This is the Whirlpool Galaxy, known by astronomers as M51, a place where beauty and mystery collide on an unimaginable scale. 23 million light-years away from us, its spiral arms stretch across the void like a celestial fingerprint, each twist and turn hiding secrets that defy our understanding of space. But what makes this galaxy so special isn't just its breathtaking appearance, it's the sheer number of strange, unexplained phenomena lurking within its stars, dust, and dark corners. From bizarre radio signals to structures that shouldn't exist, the Whirlpool Galaxy is a treasure chest of cosmic riddles, and today we're opening it wide. Think about that distance for a moment: 23 million light-years. The light we're seeing now left that galaxy when Earth's early ancestors were just taking their first steps. And yet, despite the unfathomable gap, M51 feels almost alive, pulsing with activity that challenges everything we think we know. It's a hotspot for cosmic oddities, a place where the rules of physics seem to bend, and where astronomers keep stumbling upon discoveries that leave them speechless. Why here? What is it about this galaxy that makes it such a magnet for the unexplained? That's the journey we're about to take together, diving deep into 50 of its most bewildering phenomena, each one more fascinating than the last. This isn't just a tour of distant stars and gas clouds. It's an invitation to explore the edges of our knowledge. Some of these mysteries might hold clues to the very fabric of the universe, while others seem to taunt us with questions that have no answers yet. And that's the thrill of it, because every time we look at the Whirlpool Galaxy, it reminds us that the universe is stranger, more dynamic, and more wondrous than we could ever imagine. So, are you ready to step into the unknown, to unravel the enigmas of a galaxy that refuses to play by the rules? Let's begin. At the heart of the Whirlpool Galaxy, something isn't right. In most spiral galaxies like our own Milky Way, you'd expect to find a supermassive black hole anchoring the core, a gravitational titan millions of times heavier than the Sun. But M51 isn't playing by the rules. When astronomers pointed their telescopes toward its center, they found something baffling. The usual signs, the intense X-ray flares, the swirling maelstrom of stars orbiting an invisible point, were strangely muted. Some observations even hinted that the black hole might not be there at all. This isn't just a case of a shy cosmic predator. If the black hole is truly missing, it would upend our understanding of how galaxies form. These colossal objects are thought to be the engines of galactic evolution, shaping everything from star formation to the structure of the spiral arms themselves. So where did it go? One theory suggests it might be obscured by an unusually thick veil of dust hiding its telltale emissions. Another, more radical idea proposes that the black hole was ejected entirely, catapulted out of the galaxy by some unimaginable gravitational slingshot. Imagine that, a supermassive black hole flung into the void like a cosmic outcast, but the plot thickens. Recent studies have detected faint whispers of activity in the core, flashes of energy that could hint at a black hole still lurking there, just dormant or starving. If that's true, it raises even more questions. Why is it so quiet? Is it temporarily shut down, or is it trapped in some strange state we've never seen before? Every answer leads to deeper mysteries, and that's what makes the Whirlpool Galaxy so captivating. It's not just showing us the unknown, it's forcing us to rethink what we thought we knew. Move away from the galaxy's enigmatic core, and you'll stumble upon another puzzle lighting up the Whirlpool's spiral arms, mysterious beacons of X-rays burning brighter than anything in our cosmic neighborhood. These aren't your average stellar remnants or run-of-the-mill black holes. Known as ultra-luminous X-ray sources, or ULCs, they defy expectations by pouring out enough energy to outshine a million suns combined. What powers these celestial lighthouses? Even the most seasoned astronomers are still scrambling for answers. One leading theory points to intermediate mass black holes, cosmic middleweights bridging the gap between small stellar black holes and the supermassive giants at galactic centers. Imagine an object tens of thousands of times heavier than our Sun, greedily slurping up surrounding gas and dust. The friction from this feast would generate those jaw-dropping X-ray flares. But here's the catch. While we've found plenty of small and supermassive black holes, these elusive middle siblings remain frustratingly rare. If Galaxies are their calling cards, the Whirlpool Galaxy might be hiding an entire population of them, rewriting the rules of black hole evolution. Then there's the wildcard possibility: exotic stellar objects pushing the limits of physics. Picture a neutron star, the dense corpse of a dead star, spinning so fast and wrapped in such a strong magnetic field that it accidentally mimics a black hole's appetite. Some Galaxies might actually be these magnetized powerhouses, their beams of radiation focused into narrow jets by cosmic forces we barely understand. It's like finding a flashlight in the wilderness, only to realize it's somehow brighter than the sun. But the plot gets stranger. A handful of these X-ray hotspots flicker unpredictably, flaring and dimming in ways that don't match any known cosmic behavior. Could there be entirely new classes of objects lurking here? Or are we witnessing rare, short-lived events, collisions, disruptions, or births that leave behind these brilliant afterglows? Every observation deepens the mystery, turning the Whirlpool Galaxy into a cosmic laboratory where the universe tests its most extreme physics. What's clear is this: each ULX is a clue, a piece of a puzzle that stretches far beyond M51. Solving it could unlock secrets about how black holes grow, how stars meet their violent ends, and even how galaxies distribute their energy. For now, these brilliant enigmas keep astronomers glued to their telescopes, reminding us that sometimes the universe's most dazzling lights shine to lead us into the darkest corners of the unknown. Among the Whirlpool Galaxy's grand spiral arms, one stands out for all the wrong reasons: a faint, fragmented structure that seems almost out of place. Dubbed the Ghost Arm, this ethereal wisp of stars and gas curls through space like a half-forgotten echo of the galaxy's usual grandeur. Unlike the bright, well-defined arms brimming with young stars and glowing nebulae, this one is patchy, disjointed, as if someone smudged a stroke of paint across a masterpiece. So what exactly are we looking at? The answer might lie in the Whirlpool's turbulent past, or in the gravitational tricks played by its chaotic dance with its companion, NGC 5195. One compelling theory suggests this ghostly arm is a cosmic scar, a relic from a violent collision millions of years ago. Galaxies don't merge neatly, they tear into each other, flinging stars and gas into chaotic new orbits. Picture two dancers spinning too close, their arms tangling and stretching before finally pulling apart. The Whirlpool's faint arm could be the aftermath of such an encounter, a debris trail left behind as NGC 5195 grazed past. Observations reveal stars in this arm move at odd angles, their motions out of sync with the rest of the galaxy. It's as if we're seeing the galactic equivalent of a ship's wake, churned up by a passing titan. But there's another explanation, one that leans into the strange sorcery of gravity. When galaxies interact, their gravitational pull can warp space itself, distorting the shapes of their neighbors like reflections in a funhouse mirror. NGC 5195's relentless tug might have stretched one of the Whirlpool's arms thin, siphoning away its stars and gas until only this ghostly remnant remained. Computer simulations show such interactions can create phantom arm structures that aren't physically separate but appear so because of how gravity bends light and motion. It's an illusion on a galactic scale, a trick of perspective that leaves astronomers questioning what's real and what's just cosmic sleight of hand. The mystery deepens when you consider the arm's unusual composition. While most spiral arms are factories of star birth, bustling with young, blue stars and glowing nebulae, this one is eerily quiet. Scattered older stars and dim pockets of gas dominate the region, suggesting it's either a graveyard of past activity or a structure that never quite got the chance to thrive. Some researchers argue this points to the arm being a temporary feature, a fleeting ripple in the galactic pond, destined to fade as the Whirlpool and its companion continue their slow-motion waltz. Yet the most tantalizing possibility is that we're seeing both explanations at once. The ghost arm might be a fossil of an ancient collision, reshaped over eons by M5195's relentless gravity. It's a reminder that galaxies aren't static paintings but dynamic, ever-evolving entities, where violence and time weave together into something new. Every observation peels back another layer, revealing just how much we still have to learn about the forces that sculpt the cosmos. And in the Whirlpool Galaxy, even the faintest whispers of light can tell the loudest stories. Nestled within the Whirlpool Galaxy's sprawling arms, two stellar nurseries defy logic, cosmic twins born from the same galactic neighborhood, yet utterly alien to one another. These regions, brimming with newborn stars and churning clouds of gas, should be chemical siblings sharing the same building blocks of the universe. But when astronomers analyzed their composition, the results were staggering. One nursery glows with a rich cocktail of heavy elements: carbon, oxygen, iron, while its neighbor, barely a stone's throw away in cosmic terms, is eerily pristine, dominated by ancient hydrogen and helium as if time forgot it. How can two patches of the same galaxy, close enough to whisper to each other, be so fundamentally different? The first clue might lie in the violent lives and deaths of massive stars. Supernovas are the universe's ultimate alchemists, forging heavier elements in their cores before scattering them across space in catastrophic explosions. If one of these nurseries sits atop the graveyard of a recent supernova, its gas clouds could be saturated with these stellar ashes, seeding the next generation of stars with a wealth of metals. Meanwhile, the other nursery might have been spared, sheltered from the blast by a fortuitous veil of dust or the sheer randomness of cosmic geography. Picture two gardens side by side, one fertilized by a volcanic eruption, the other untouched, its soil still primordial. But there's a twist. Some researchers argue this imbalance isn't just luck, it's sabotage. The Whirlpool Galaxy's smaller companion, M5195, might be the invisible hand stirring the pot. As it tugs gravitationally on M51, it could be funneling fresh, uncontaminated gas from the galactic outskirts into one nursery while leaving the other to recycle older, metal-rich material. It's like a cosmic conveyor belt, delivering ingredients from opposite ends of the galaxy's pantry. Then there's the rogue possibility: external contamination. Galaxies aren't closed systems, they steal from each other. A long-ago encounter with a dwarf galaxy or a wandering gas cloud could have dumped a surge of primordial fuel into one nursery, resetting its chemical clock. Imagine a splash of ink dropped into one glass of water while the other remains crystal clear, except here, the ink is the raw stuff of the early universe, and the glasses are light-years-wide cauldrons of star birth. What makes these twins so fascinating isn't just their differences, it's what they reveal about the chaos of galaxy evolution. Normally, astronomers expect chemistry to smooth out over time, with older regions growing metal-rich as generations of stars enrich their surroundings. But the Whirlpool Galaxy flips that script, proving that cosmic neighborhoods can stay stubbornly mismatched, their identities shaped by violence, chance, and the invisible pull of galactic neighbors. Every star born in these nurseries carries a fingerprint of that history, a silent witness to the forces that built and keep reshaping this mesmerizing whirlpool of stars. Imagine a star traveling so fast it could cross the length of our solar system in just a few days, not orbiting the galactic core like the rest of its siblings, but hurtling outward as if thrown by some unseen cosmic hand. In the Whirlpool Galaxy, these hypervelocity stars exist, and they're racing toward intergalactic space at speeds topping 2 million miles per hour. What kind of force could launch a star with such violence? The answer lies in a celestial game of gravitational pinball, where black holes, galactic collisions, and pure cosmic chance conspire to turn stars into interstellar fugitives. The prime suspect, the Whirlpool's smaller companion, NGC 5195. As this dwarf galaxy tugs and twists M51's spiral arms, its gravitational pull doesn't just warp gas clouds, it can slingshot stars into oblivion. Picture a marble rolling too close to a spinning top. The sudden jolt sends it flying. Now scale that up to a star weighing billions of times more, whipped into motion by the dance of two galaxies. But here's the twist. Some of these runaway stars aren't just fleeing the disk, they're being spat out at angles that don't match NGC 5195's trajectory. That's where the galaxy's hidden players come in. Black holes, especially binary systems where two orbit each other, might be the ultimate cosmic catapults. If a star wanders too close to this dueling pair, the complex gravitational tug of war can fling it away like a stone from a sling. Simulations show these encounters can accelerate stars to jaw-dropping speeds, turning them into what astronomers call hypervelocity escapers, objects so fast they'll eventually leave their home galaxy entirely. In the whirlpool where black holes might lurk unseen, this could explain why stars are launching from seemingly random directions. Yet the weirdest part isn't their speed, it's their survival. Most stars ejected this violently should tear themselves apart, their outer layers stripped by tidal forces. But in M51, many runaways shine brightly, intact and defiant. One theory suggests these might be compact, dense stars like blue stragglers, their sturdy cores weathering the chaos. Others speculate they were part of binary systems, their partners sacrificed in the gravitational upheaval, leaving solitary survivors to streak across the cosmos. What awaits these stars? A lonely future. Unlike the bustling spiral arms they left behind, intergalactic space is a near-perfect void. With no planets to warm or nebulae to illuminate, they'll drift until their light fades into the endless dark. But for astronomers, they're more than just curiosities, they're celestial breadcrumbs. By tracing their paths backward, we might map the whirlpool's most violent events, uncovering hidden black holes or long-forgotten collisions. Every runaway star is a relic of chaos, a testament to the forces that shape galaxies not just through creation, but through explosive escape. The Whirlpool Galaxy spins with an eerie rhythm that shouldn't be possible unless something invisible is pulling the strings. When astronomers mapped its rotation curve, tracing how fast stars and gas move at different distances from the core, they expected a gentle decline in speed as you move outward, like planets slowing down farther from the sun. But M51 laughs at expectations. Its outer regions whip around just as fast as the inner ones, defying gravity's usual rules. The culprit, a hidden skeleton of dark matter, woven through the galaxy in a halo so massive it outweighs all visible stars and gas combined. Yet even here, the whirlpool refuses to be ordinary. This isn't a smooth, symmetrical halo. It's lumpy, warped, as if stitched together from mismatched parts. Dark matter halos are supposed to be the universe's quiet architects, their gravity sculpting galaxies into orderly spirals. In most cases, they're roughly spherical, thinning out evenly in all directions. But the whirlpool's halo betrays strange asymmetries, with dense clumps on one side and ghostly gaps on the other. One theory points to its gravitational tango with NGC 5195. As the smaller galaxy tugs on M51, it might be shredding the dark matter halo like a spoon stirring honey, leaving behind swirls and voids. Picture a candle flame bending in the wind, except here, the flame is an invisible force bending the fabric of space itself. Then there's the possibility of missing pieces. Some models suggest parts of the halo could have been torn away entirely during ancient collisions, carried off by rogue galaxies or scattered into intergalactic space. It's like finding a shattered vase where half the fragments have vanished without a trace. These gaps would create odd pockets where stars move too fast or too slow, like cars on a highway suddenly hitting patches of ice. Astronomers have spotted such anomalies in the Whirlpool's outer reaches, regions where the rotation curve stutters, as if the galaxy's hidden hand occasionally falters. But the boldest idea, the halo might not be pure dark matter at all. A handful of theorists argue these discrepancies hint at something even stranger, exotic particles interacting weakly with each other or even decaying over time. If true, the Whirlpool's dark matter could be slowly evaporating, its invisible grip on the galaxy weakening in ways we're only beginning to detect. Every flicker in the rotation curve, every stray star moving out of step, could be a clue to forces beyond our current physics. What's certain is this: the Whirlpool's dark matter isn't just a passive scaffold. It's dynamic, messy, and intimately tied to the galaxy's turbulent history. By studying its quirks, we're not just unraveling the secrets of one galaxy, we're peering into the shadowy framework that holds the entire universe together. And if this halo can defy expectations, what else might be hiding in the dark? Deep within the Whirlpool Galaxy's core, a silent scream echoes across the cosmos, not in light but in radio waves. Astronomers tracing these faint signals stumbled upon a structure so bizarre it defies textbook explanations. A colossal jet of charged particles, stretching thousands of light years from the galaxy's heart, twisted into shapes that shouldn't exist. Most supermassive black holes eject matter in neat, symmetrical beams, like water from a hose. But M51's jet writhes like a snake mid-strike, kinked and knotted in ways that leave physicists scrambling for answers. Is this the aftermath of a recent eruption or evidence of a black hole playing by its own rules? The anomaly's first clue lies in its youth or lack thereof. Jets from active black holes typically flare brightly for a few million years before fading. Yet this one shows no signs of dimming, its radio glow steady across decades of observations. That persistence suggests something unusual is feeding it, like a fire that refuses to burn out. One theory points to the galaxy's companion, NGC 5195, as an accomplice. As it swings close during its orbital dance, it might funnel fresh gas toward the black hole, stoking the jet like oxygen to a flame. Imagine a bonfire fed by gusts of wind, except here, the wind is an entire galaxy, and the fire is a particle beam hotter than a supernova. But the jet's chaotic shape tells an even stranger story. Instead of streaming outward in a straight line, it fractures into filaments, some curving backward as if caught in a cosmic undertow. Simulations blame the Whirlpool's own atmosphere, a thick soup of gas and magnetic fields that could bend and shred the jet like paper in a storm. Yet even these models can't explain the jet's most baffling feature: bright knots that pulse irregularly, flaring and vanishing faster than black hole physics allows. Some researchers whisper about magnetically arrested disks, a state where the black hole's magnetic field grows so strong it chokes off its own feeding frenzy, triggering explosive releases of energy. Others propose we're seeing echoes of past eruptions, their remnants colliding like ripples in a pond. The boldest hypothesis: this isn't one jet at all, but two or more overlapping in time and space. Black holes can switch ejection angles over millennia, creating a layered legacy of outbursts. If the Whirlpool's core has been flickering on and off like a faulty engine, each new jet might plow through the debris of its predecessors, creating a tangle of radio light. It's like listening to an orchestra where every musician plays a different symphony at once. Untangling that cacophony could reveal hidden rhythms in how black holes feed, sleep, and reawaken over cosmic time. For now, the jet remains a riddle wrapped in an enigma, its very existence challenging our assumptions about how black holes shape their galaxies. Whether it's a sign of ongoing turmoil or a relic of ancient violence, one thing is clear: the Whirlpool's heart doesn't just beat, it roars. And with every pulse, it reminds us that even the universe's most predictable engines can spit out surprises. Tucked away in one of the Whirlpool Galaxy's spiral arms, a celestial retirement home burns brighter and stranger than it should. This is no ordinary cluster of stars. It's a gathering of red supergiants, massive stars in their final fiery chapters, each one large enough to swallow our solar system whole. But something's off. These aging giants shouldn't exist in such numbers here, packed together like overripe fruit on a cosmic branch. Even stranger, they're showing signs of accelerated decay, as if some unseen force is fast-forwarding their inevitable collapse into supernovas. What could possibly make stars age unnaturally fast in a galaxy already brimming with mysteries? The most obvious culprit lies in the stars themselves. Red supergiants are known for their violent stellar winds, rivers of gas they shed into space as they near death. Normally, this process takes millions of years, but in this cluster, the winds rage with unprecedented ferocity. Spectroscopic readings reveal these stars are ejecting material at speeds up to twice the norm, almost as if they're hemorrhaging their own mass. One explanation points to intense magnetic fields churning beneath their surfaces, twisting and amplifying until they literally tear the stars apart from within. Picture a pot of boiling water with the lid clamped down too tight. Eventually, the pressure blows. Except here, the pot is a star, and the steam is a hurricane of plasma scouring the surrounding void. Yet stellar winds alone can't explain the cluster's other oddity, its location. These supergiants huddle in a region dense with interstellar gas, a detail that sends theorists scrambling. Normally, such environments slow stellar winds, creating a cushion that prolongs a star's life. But in this pocket of the whirlpool, the opposite seems true. Some speculate the gas here might be unusually enriched with heavy elements, making it more corrosive, like sandblasting a statue with metal filings instead of dust. Over time, this abrasive medium could strip away the star's outer layers far quicker than nature intended. It's as if the galaxy itself is peeling them apart, hastening their demise. Then there's the wild card, external sabotage. The Whirlpool's companion galaxy, NGC 5195, casts a long gravitational shadow. As it tugs on M51, it could be compressing gas clouds in this region, triggering waves of star formation that all ignite around the same time. If these supergiants were born in a single, frantic burst of creation, they might now be dying in unison, a stellar generation bound by shared fate. Even more intriguing, some models suggest the cluster could be experiencing a rare, induced collapse, where radiation from nearby supernovas or black holes bombards the stars, destabilizing their cores like a nuclear chain reaction. Imagine standing too close to a series of explosions. Eventually, the shockwaves would rattle you apart, but the most haunting possibility is that we're witnessing a cosmic domino effect. Perhaps one star in the cluster began its death spiral early, a massive supergiant collapsing into a black hole or neutron star. The resulting shockwave rippling through the neighborhood could have triggered its neighbors to accelerate their own demise. In this scenario, the cluster isn't just aging fast, it's dying in a synchronized cascade, each supernova nudging the next closer to the brink. Whatever the cause, this crimson cluster offers a grim preview of stellar mortality on overdrive. For astronomers, it's a laboratory for understanding how stars cheat time and what happens when the universe hits fast forward. The answers might rewrite our playbook for how galaxies and the stars within them burn bright then fade. And somewhere in that violent glow, the whirlpool whispers yet another secret, that even the mightiest stars don't always get to choose when their light goes out. The Whirlpool Galaxy glows not just in visible light but in high-energy gamma rays, some of the most violent photons the universe can produce. Scattered across its spiral arms, telescopes have pinpointed mysterious hotspots where gamma rays flare unpredictably, defying easy explanation. These aren't the steady hum of known pulsars or the aftermath of supernovas. Instead, they pulse and fade like cosmic lighthouses switched on at random, hinting at forces at work we've yet to fully grasp. One leading suspect, hidden pulsars, ultra-dense neutron stars spinning so fast their magnetic fields whip particles to near light speed, producing gamma-ray beams that slash across space like celestial searchlights. Ordinarily, we'd detect their rhythmic pulses, but in the whirlpool, many of these hotspots flicker erratically. Some might be orphaned pulsars, their rotation axes wobbling wildly after violent bursts, their beams sweeping past Earth at irregular intervals. Others could be shrouded in thick debris clouds, their usual radio whispers smothered, leaving only gamma-ray screams piercing the darkness. Imagine trying to spot a lighthouse during a storm. You'd only catch glimpses when the fog momentarily clears. Then there's the darker possibility, dark matter annihilation. If these invisible particles truly make up most of the galaxy's mass, they might occasionally collide, obliterating each other in bursts of energy. The whirlpool's twisted dark matter halo could create dense pockets where such collisions occur more frequently, igniting these gamma-ray beacons. It's a tantalizing thought that we might be witnessing the fingerprints of the universe's most elusive substance, not through its gravity but through its self-destruction. But the plot thickens with cosmic rays, high-energy protons and atomic nuclei hurtling through space. When these particles slam into gas clouds or interstellar dust, they can spark gamma-ray flashes like celestial fireworks. The whirlpool's turbulent arms, brimming with star-forming regions and supernova shocks, might act as cosmic accelerators, revving up particles to energies beyond anything we can recreate on Earth. Some hotspots could mark the sites of ancient stellar cataclysms, their shockwaves still rippling through the galaxy's gas, turning it into a vast particle collider. What makes these hotspots so perplexing is their inconsistency. Some vanish within months while others linger for years. A few even reappear in slightly different locations, as if whatever's powering them is moving. Could we be seeing the trails of rogue black holes plowing through gas clouds, or the wakes of hypervelocity stars mentioned earlier, their bow shocks lighting up the interstellar medium? Each flare is a breadcrumb, a clue to processes that shape galaxies in ways we're only beginning to untangle. And in the whirlpool, where mystery piles upon mystery, these gamma-ray enigmas remind us that even the most violent light can illuminate the darkest corners of our understanding. In the Whirlpool Galaxy's sweeping arms, some roads simply end. Not the star-studded paths you'd expect, but the dark, dusty lanes that typically weave through spiral galaxies like veins through a leaf. These dust corridors are supposed to be persistent, lingering for millions of years as they birth new stars. But in M51, astronomers have mapped eerie zones where the dust doesn't thin gradually, it drops off a cliff. One moment you're peering through a murky cosmic river, the next it's gone, leaving behind a stark, starry void. What cosmic eraser could scrub away dust so thoroughly, and why here? The prime suspect, radiation pressure from the galaxy's most ravenous stellar giants. Massive stars don't just shine, they blast their surroundings with ultraviolet light so intense it can push dust grains outward like leaves in a hurricane. In regions crowded with these luminous behemoths, the combined force might be ejecting dust entirely, clearing pockets at speeds topping hundreds of miles per second. Imagine a dozen fire hoses aimed at a sandcastle. The structure doesn't just dissolve, it's launched into oblivion. The whirlpool's most dramatic dust gaps align suspiciously with clusters of O-type stars, the universe's equivalent of cosmic blowtorches. Their radiation could be carving these voids, sculpting the galaxy in ways we're only beginning to measure. Yet not every dust desert sits near obvious stellar culprits. Some border seemingly quiet patches of space, raising the possibility of invisible forces at work. Enter magnetism. Galactic magnetic fields, though imperceptible to human eyes, can stretch across light years, guiding dust like iron filings on a sheet of paper. If the whirlpool's magnetic web is unusually tangled here, perhaps twisted by past collisions or NGC 5195's gravitational nudges. It might be funneling dust into hidden streams or compressing it into dense knots. Telescopes have spotted similar magnetic drapes in other galaxies, where dust appears to vanish only to pile up just out of sight behind curtains of polarized starlight. But the strangest cases show dust lanes not just fading, but reforming elsewhere, like smoke rings dissolving and reappearing across a room. These could be signs of dust waves, shock fronts from ancient supernovas, or black hole outbursts sweeping through the galaxy. As these waves pass, they might scatter dust particles into new configurations, leaving behind temporary voids before the material drifts back. It's a celestial game of hide and seek, with the whirlpool's dust acting less like a permanent feature and more like a fluid reshaped by the galaxy's hidden tides. The implications reach far beyond aesthetics. Dust isn't just galactic decoration, it's the raw material for planets and the smog that obscures our view of the universe's depths. If the whirlpool's dust lanes are this dynamic, it could mean star formation here follows rhythms we've barely begun to decode. One thing's certain, in a galaxy already teeming with enigmas, even the absence of something becomes a clue. And these ghostly gaps, they're not empty, they're silent witnesses to forces powerful enough to rewrite the galaxy's blueprint on the fly. Hiding in plain sight behind the Whirlpool Galaxy's spiraling disk, two brilliant pinpoints of light appear perfectly aligned, like cosmic headlights piercing through a fog of stars. At first glance, they seem part of M51 itself, but the truth is far stranger. These are quasars, some of the universe's most luminous objects, blazing from unimaginable distances far beyond the whirlpool. Their precise alignment is a fluke of galactic geometry, a fleeting illusion made possible by the universe's love of trickery and the bizarre magic of gravity itself. Gravitational lensing, the phenomenon bending light around massive objects, is usually the culprit behind such cosmic mirages. But here's the twist: the Whirlpool Galaxy isn't massive enough to lens these quasars visibly. Instead, their alignment is pure chance, a testament to how crowded the cosmos truly is. Picture holding a flashlight behind a spinning pinwheel. By sheer luck, the beam might shine through two gaps in the blades at once. In this case, the pinwheel is the whirlpool, and the flashlights are quasars, each one a galaxy core powered by a supermassive black hole feasting on gas so furiously it outshines every star in its host galaxy combined. What makes this duo especially rare isn't just their alignment, it's their partnership. Binary quasars themselves are extraordinarily uncommon, occurring when two galaxies collide, driving their central black holes into a shared feeding frenzy. For both members of such a pair to line up perfectly with another galaxy's disk from our vantage point, the odds are astronomical. Simulations suggest we're seeing a snapshot that would vanish with even a slight shift in perspective, like catching two speeding trains on parallel tracks at the exact moment they overlap from your window. The illusion's real gift to science lies in what it reveals about the whirlpool's structure. As the quasar's light filters through M51's dust and gas, their spectra carry fingerprints of the material they've passed through. Astronomers have used this backlighting to map hidden pockets of cold hydrogen and traces of heavy elements in the galaxy's outer arms, regions too dim to study otherwise. It's as if the universe handed us a flashlight and an X-ray machine at once, letting us peer into the whirlpool's shadowy corners. Yet the most dazzling detail might be how temporary this alignment is. The whirlpool rotates, the quasars move. In a few million years, a blink in cosmic time, their perfect lineup will dissolve, leaving no trace of the illusion behind. For now, though, it stands as a reminder that even the universe's grandest structures can conspire to create moments of fleeting, impossible beauty. And in a galaxy already overflowing with wonders, these phantom beacons ask us, what other tricks might the cosmos have up its sleeve? Among the Whirlpool Galaxy's graveyard of dead stars, two supernova remnants tell a story that shouldn't make sense. a pair of cosmic doppelgangers separated by millions of years. At first glance, they're nearly identical, same intricate lacework of glowing filaments, same sprawling diameter, even the same haunting symmetry in their debris fields. But here's the catch: spectroscopic dating reveals one is a fresh corpse, its light reaching us just a few thousand years after the explosion, while the other faded into invisibility long before Earth's pyramids were built. How could two stellar deaths spaced so far apart in time leave behind such eerily matched ruins? The simplest explanation might lie in the stars themselves. Twin supernovas require twin progenitor stars born from the same stellar nursery, with nearly identical mass and composition. If these siblings ignited and burned fuel at the same rate, they could have exploded in the same way, just at wildly different times. Imagine two candles molded from the same wax, braided with identical wicks, light one today, the other a decade later, and they'll burn with matching flickers. In cosmic terms, these stars might have been near-perfect copies, their fates preordained by shared genetics, but there's a problem with this tidy theory. Supernovas are chaotic, their shockwaves shaped by tiny differences in a star's rotation, magnetic fields, or surrounding gas. Even clones shouldn't leave such pristine mirror images. That's led some researchers to suspect something stranger, that the whirlpool structure itself guided these explosions into symmetry. The galaxy's magnetic fields, woven through its spiral arms like invisible threads, could have funneled debris into eerily similar patterns. Or perhaps both remnants expanded into identical pockets of interstellar gas, their shockwaves sculpted by the same density barriers. It's like watching two landslides tumble down the same mountainside years apart. The terrain forces them into matching paths. Then there's the wild card, pure cosmic coincidence. With enough supernovas scattered across a galaxy, statistics say a few should resemble each other by chance alone. But the odds of such perfect symmetry are vanishingly small, like rolling double sixes 100 times in a row. That improbability has theorists revisiting exotic explosion mechanisms. Could some stars collapse in a way that naturally favors certain debris patterns? One controversial model suggests rapidly spinning progenitors might fracture along preferred axes, like glass shattering along hidden flaws, producing similar remnants regardless of age. The truth might lie in the remnant's surroundings. Recent radio observations show both sit atop faint, overlapping bubbles, ghostly imprints of older supernovas that cleared out cavities in the interstellar medium. If each new explosion erupted inside one of these pre-carved chambers, their shockwaves would hit identical walls of gas, rebounding into matching shapes. It's a celestial echo chamber where the ghosts of past stellar death shape the corpses of future ones. For astronomers, these mirror image remnants are more than curiosities, they're cosmic experiments. By comparing their chemistry, temperature, and motion, we might crack the code of how stars die and why the universe sometimes repeats itself. In the Whirlpool Galaxy, even destruction has a curious habit of rhyming. In the swirling depths of the Whirlpool Galaxy, there exists an enormous, eerie blank spot. A region spanning thousands of light years where neutral hydrogen, the universe's most abundant building block, has mysteriously vanished. Known as an H1 hole, this void isn't just a minor gap in the galactic fabric. It's a cosmic desert, conspicuously empty in a galaxy otherwise teeming with star-forming gas. How does a galaxy lose something as fundamental as hydrogen? The answer may lie in the whirlpool's violent past or in the relentless energy of its brightest stars. One possibility points to a cataclysmic merger. When galaxies collide, their gravitational forces create shockwaves powerful enough to fling gas out into intergalactic space. The whirlpool's smaller companion, NGC 5195, could have plowed through this region millions of years ago, its gravitational pull acting like a cosmic plow, shoveling hydrogen out of the way and leaving behind this barren stretch. Computer simulations show such interactions can carve vast cavities, with some gas falling inward to feed new star formation while the rest is ejected entirely. It's like a meteor striking a lake. Some water splashes back in, but much of it is lost to the air. But there's another, more explosive explanation: stellar feedback. In areas where star formation runs rampant, massive stars live fast and die violently. Their intense radiation and eventual supernova explosions can heat nearby hydrogen to extreme temperatures, ionizing it so thoroughly that it escapes detection by radio telescopes, the tools astronomers typically use to map neutral hydrogen. The Whirlpool's spiral arms are factories of star birth, and if this hole sits in a region where multiple generations of stars have flared up and burned out, their combined energy might have scoured the area clean. Picture a wildfire sweeping through a forest, leaving behind only scorched earth, except here, the fire is starlight and the earth is an ocean of gas. Yet the plot thickens with an odd detail: the hole's edges are razor sharp. If stellar winds or supernova were responsible, we'd expect a more gradual tapering of gas density. Instead, this void ends abruptly, as if sliced away by an invisible blade. Some theorists propose an unseen force, perhaps a concentrated burst of energy from the galaxy's active core millions of years ago, or even a rogue black hole passing through, its gravity vacuuming up the hydrogen in its path. Others wonder if dark matter plays a role. Could an unusually dense knot of this mysterious substance be warping space here, creating a gravitational sink that diverts hydrogen away like a cosmic drainage ditch? Whatever the cause, this hydrogen hole isn't just an absence, it's a fossil record. By studying its shape and surroundings, astronomers can piece together the Whirlpool's history of collisions, bursts of star formation, and even the invisible forces that shape galaxies from within. In a universe where gas is the currency of creation, this empty patch is a stark reminder. Sometimes the most telling clues aren't what's present, but what's conspicuously missing. Scattered like ancient relics across the Whirlpool Galaxy, certain star clusters defy time itself, globular formations where stellar aging appears to grind to a halt. These clusters, each packed with hundreds of thousands of stars, should follow predictable life cycles, stars burning through their fuel, swelling into red giants and fading into stellar embers. But in these peculiar pockets, evolution stalls. Stars that should have died eons ago burn on, suspended in cosmic amber. What could possibly press pause on the life cycle of an entire stellar population? The answer might lie in forces unseen, or in the galaxy's hidden capacity to rewrite the laws of physics. One explanation points to dark matter's invisible hand. Most globular clusters orbit galaxies like loose swarms, barely interacting with the mysterious substance that dominates galactic halos. But if these anomalous clusters drifted too close to dense dark matter clumps, knots of the invisible material threading through the whirlpool, they might have been bathed in its influence. Simulations suggest dark matter particles could siphon energy from stellar cores, slowing nuclear fusion rates like a cosmic thermostat turned low. Picture a campfire doused with invisible water, its flames flickering slower but never snuffing out. If true, these clusters aren't just oddities, they're living detectors. They're stars betraying dark matter's presence through their unnatural longevity. Yet there's a competing theory: external pollution. As the Whirlpool Galaxy cannibalized smaller neighbors over billions of years, it might have ingested clusters already packed with stellar stragglers, stars artificially rejuvenated by stealing fuel from companions. Binary star systems, locked in tight dances, can transfer mass between one another, allowing older stars to gorge on fresh hydrogen like celestial vampires. In the chaos of galactic mergers, these invigorated stars could have been dumped into ordinary clusters, masquerading as timeless anomalies. Telescopes have spotted hints of this in the Whirlpool's outer halo, where clusters exhibit bizarre chemical imbalances, extra sodium, depleted oxygen, as if their stars were contaminated by an ancient theft. Then comes the radical possibility: interrupted physics. Stars in these clusters might be tapping into energy sources we've never observed. Quantum phenomena or exotic particles could alter fusion processes at their cores, stretching their lifespans far beyond standard models. It's like discovering a forest where trees grow to twice their expected height because the soil secretly filters time. Some theorists even speculate about Q stars, hypothetical dense objects stabilized by undiscovered forces lurking within these clusters, their presence warping the behavior of neighboring stars. While fringe, the idea underscores how profoundly puzzling these clusters are. The implications ripple far beyond the whirlpool. If dark matter can stall stellar aging, it might explain why some galaxies host stars older than the universe itself seems to allow. If stellar piracy is the culprit, it reveals how violently galaxies recycle their resources. And if new physics is at play, these frozen clusters could be the first clue to rewriting astrophysics itself. For now, they stand as celestial paradoxes, places where time loses its grip, and the universe whispers secrets we're only beginning to hear. The Whirlpool Galaxy isn't content with just spinning gracefully. Its outskirts might be hiding an architectural oddity so rare it defies expectations. Nestled beyond its well-defined spiral arms, astronomers have detected faint, looping structures that curve at nearly right angles to the galactic disk, like a cosmic hula hoop wrapped around the galaxy's waist. This isn't just a minor wrinkle, it's a potential polar ring, a feature usually seen in galaxies that have survived violent mergers. But here's the twist: M51's elegant spirals show no signs of such a catastrophic past. So why does it bear the scars of a collision it seemingly never had? The leading suspect, as usual, is the Whirlpool's relentless dance partner, NGC 5195. Polar rings typically form when a smaller galaxy is torn apart during a merger, its stars and gas strewn into a perpendicular orbit around the larger survivor. But the Whirlpool's spiral structure remains remarkably intact, suggesting a gentler interaction, one where gravity alone might be sculpting this anomaly. Picture NGC 5195 as a cosmic sculptor, its gravitational tugs not just warping M51's arms but also stirring its outermost halo into this strange ring-like ripple. Unlike a full merger where chaos reigns, this could be a subtler rearrangement, like a slow-motion tug of war between two giants, where the loosest material gets flung into an unnatural orbit. Yet there's a puzzle nestled in the ring's composition. Polar rings are usually rich in gas and young stars, their fresh material stolen from ill-fated companions. But preliminary observations suggest the Whirlpool's possible ring is oddly quiet, populated mostly by older stars and faint streams of dust. This mismatch has led some astronomers to wonder if we're seeing something even rarer: a dark ring, a structure shaped not by stolen gas but by the invisible pull of dark matter. If NGC 5195's halo overlaps with the Whirlpool's in just the right way, their combined gravitational fields could have sculpted this ghostly orbit, a path traced not by stars or gas but by the unseen scaffolding of the universe itself. The real enigma, though, is time. Polar rings are thought to be fleeting, lasting only a few 100 million years before dispersing or settling into the galactic disk. If this ring is real, its persistence suggests the Whirlpool's gravitational dynamics are far more complex than we imagined. Perhaps the ring is constantly replenished, with NGC 5195's nudges keeping it stable like a spoon stirring a cup of tea. Or maybe it's not a ring at all, but a chance alignment of tidal debris, the frayed edges of M51's outer halo, twisted into a temporary illusion by our line of sight. For now, the ring remains a tantalizing maybe, its existence hovering at the edge of detection. But if confirmed, it would force us to rethink not just the Whirlpool's history, but how galaxies evolve in close quarters. Some interactions leave visible bruises, others write their secrets in whispers of starlight, waiting centuries for us to decipher them. And in a galaxy already brimming with mysteries, this phantom ring might just be the quietest, most elegant clue of all. Buried in the Whirlpool Galaxy's spiral arms, a cosmic strobe light pulses with unsettling irregularity, an enigmatic fast radio burst or FRB that refuses to play by the rules. Unlike most FRBs, which fire once and vanish forever, this source crackles back to life unpredictably, sometimes lying silent for months before unleashing another millisecond blast of radio energy bright enough to outshine entire stars. The signal's jagged rhythm has astronomers locked in debate. Is it the death cry of a spinning stellar corpse, or something far stranger echoing across 23 million light-years? The prime candidate, a magnetar, a neutron star with a magnetic field so intense it could erase a credit card from halfway across the solar system. When these ultra-dense stellar remnants undergo starquakes, sudden fractures in their crust, they can unleash torrents of energy, including FRBs. The Whirlpool's repeater fits part of the profile. Its bursts carry the telltale polarization twist of light traveling through strong magnetic fields. But there's a problem. Magnetar FRBs usually follow rough schedules, flaring more often as the star slows its spin. This one erupts at random, like a radio geyser with no discernible pattern. Some theorize we're witnessing a magnetar wrestling with an unseen companion, perhaps a black hole or debris disk, its gravitational tugs triggering sporadic ruptures in the star's surface. Then comes the wild card, artificial origins. While most astronomers dismiss the idea of extraterrestrial beacons, the signal's irregularity has fueled whispers of alternative explanations. Unlike human-made radio interference, which typically follows fixed frequencies, the Whirlpool's FRB shifts subtly with each burst, as if its source is moving or evolving. Could this be an alien megastructure's power surges, or a navigation pulse from a civilization harnessing energies we barely comprehend? The scientific consensus leans heavily toward natural causes, but the mere possibility underscores how little we truly grasp about these phenomena. Intriguingly, the burst's home contradicts expectations. FRB repeaters usually lurk in dwarf galaxies' chaotic environments where young magnetars abound. The Whirlpool, a grand spiral like our Milky Way, shouldn't be a hotbed for such violent stellar adolescence. This anomaly hints that either magnetars can form through unexpected channels in mature galaxies, or that another engine, perhaps colliding neutron stars or evaporating primordial black holes, might be at work. Recent observations compound the mystery. A handful of the bursts arrive with faint X-ray counterparts, suggesting the culprit is shredding surrounding material with each eruption. For now, the repeater remains a sphinx in radio waves, each burst posing more questions than answers. Whether it's a magnetar's death throes, a cosmic collision, or something beyond our current physics, one thing is clear. In a galaxy already overflowing with riddles, this flickering signal stands as one of its most tantalizing. And with every unpredictable pulse, it reminds us that the universe's most persistent mysteries often refuse to introduce themselves politely. Most black holes announce their presence with a fiery glow, the red-hot scream of matter spiraling into oblivion. But in the Whirlpool Galaxy, there's an exception to this cosmic rule, a black hole that shines an eerie electric blue. This isn't just a trick of the light. It's a fundamental defiance of what we know about how these gravitational monsters feed. The usual logic goes like this. As gas and dust fall toward a black hole, friction heats them to millions of degrees, turning the accretion disk into a crimson maelstrom. So why is this one radiating a cooler, bluer hue, like a cosmic neon sign flickering against the void? The answer might lie in the menu. Typical black holes gorge on a steady diet of interstellar gas, but this one could be feasting on something far stranger, a concentrated stream of stellar wind from nearby Wolf-Rayet stars. These monstrously luminous stars blast out material at nearly a tenth the speed of light. their winds so packed with heavy elements like carbon and oxygen that they alter the physics of the accretion disk itself. Imagine tossing metal shavings into a campfire. Suddenly, the flames burn hotter and shift color. In this case, the heavy element-rich wind slamming into the disk might be suppressing certain wavelengths of light while amplifying others, creating that surreal blue tint. But there's a twist: relativistic jets. Most black holes eject twin beams of particles at near light speed, but in this case, those jets might be plowing directly back into the inflowing matter. The collision would generate shockwaves so intense they emit synchrotron radiation, a specific type of light that leans blue. It's like watching two fire hoses blast into each other. The spray doesn't just disperse, it erupts into a fine, glowing mist. Astronomers have spotted hints of this in the Whirlpool's blue outlier faint, knotted structures near the black hole where jets and inflows might be locked in a violent embrace. Then there's the wild card: spin. Black holes rotate, and the faster they go, the more they warp space around them. A rapidly spinning black hole could be funneling matter into its disk at such extreme angles that the light emitted gets bent toward higher energies before escaping. Picture water swirling down a drain. If you spin it fast enough, the flow changes character entirely. Observations from the Chandra X-ray Observatory suggest this black hole's spin might be off the charts, turning its accretion disk into a cosmic particle accelerator that churns out blue photons like a factory. Yet the most tantalizing possibility is that we're witnessing a phase transition, a black hole switching states. Some theories suggest that under the right conditions, accretion disks can flip between stable configurations, like ice melting into water. If true, the blue hue might be a temporary signature of this shift, a fleeting glimpse of a black hole rewriting its own rules. Every flicker of that unnatural light could be a clue to processes we've never seen before, playing out on scales we're only beginning to comprehend. For now, the blue-black hole stands as a chromatic rebellion against cosmic norms. Whether it's the diet, the jets, the spin, or something entirely undiscovered, one thing is clear. In the Whirlpool Galaxy, even the darkest objects find ways to shine in colors we never expected. Deep within the Whirlpool Galaxy's spiral arms, invisible forces twist through space with impossible strength, magnetic fields crackling with energy that defies every model astronomers throw at them. These aren't just slightly off-the-mark readings, they're cosmic power lines burning 10 times hotter than they should, bending charged particles into shapes that shouldn't exist. What could possibly juice these fields to such extremes? The answer might rewrite our understanding of how galaxies generate their invisible skeletons, or hint at hidden energy sources we've never dreamed of. Picture a cosmic dynamo, the natural engine that converts a galaxy's churning gas and plasma into magnetic fields. Normally, this process caps out at predictable strengths, like a turbine limited by its fuel supply. But in these whirlpool hotspots, something's jamming the throttle wide open. One leading theory blames turbulence on steroids. Most galactic gas moves in relatively orderly flows, but here, supernova shockwaves and colliding stellar winds might be whipping plasma into fractal whirlpools within whirlpools, each twist amplifying the magnetic field like a fractal antenna tuning into some dark energy broadcast. Imagine stirring a cup of coffee with a spoon. Now replace the spoon with a jet engine and the coffee with liquid metal. That's the kind of chaos we're talking about. Yet turbulence alone can't explain the field's bizarre geometries. In one region, magnetic lines knot themselves into pretzel shapes before snapping straight like rubber bands, a phenomenon usually seen near pulsars, not floating freely in interstellar space. This has researchers scrambling for alternative explanations. Could dark matter be meddling? Certain hypothetical particles, like actions, might interact weakly with magnetic fields, subtly transferring energy over millennia. Or perhaps the Whirlpool's gravitational dance with NGC 5195 is pumping energy into the system like a cosmic swing. turning the entire galactic disk into a resonating chamber for magnetic waves. Then there's the nuclear option, literally. Buried black holes or neutron stars too dim to spot directly might be powering these fields from the shadows. When these objects accrete matter, they can launch relativistic jets that entrain magnetic fields like cosmic spider silk. If such jets plow into nearby gas clouds, they could imprint their magnetic fingerprints across light years. Some of the Whirlpool's strongest fields align suspiciously with ancient gamma-ray burst remnants, suggesting violent past eruptions might have fossilized these magnetic anomalies into the interstellar medium. But the most tantalizing clue lies in dust, not as a passive observer but as an active participant. Recent observations reveal iron nanoparticles in these regions aligning like compass needles in a factory-fresh magnetic field. Normally, such alignment takes eons, yet here it appears instantaneous, hinting at some rapid trigger mechanism. One radical paper suggests quantum phenomena in dusty plasma could briefly freeze magnetic fields at strengths far beyond classical limits, like a cosmic superconductor stuck in overdrive. Whether it's turbulence, dark matter, hidden stellar corpses, or new physics, one thing's clear. The Whirlpool's phantom fields aren't just scientific curiosities, they're proof that our maps of galactic magnetism are missing whole chapters. And with every tangled field line, this galaxy whispers a challenge. Come find what's really pulling the strings. Among the Whirlpool Galaxy's countless dying stars, two planetary nebulae glow with an impossible symmetry, identical chemical fingerprints despite being light years apart. These cosmic hourglasses, formed when aging stars shed their outer layers, usually boast unique spectra as varied as snowflakes. But here, the light signatures align perfectly, atom for atom, as if the universe photocopied one and pasted it elsewhere. Are we seeing stellar twins born from the same stellar womb, or something far stranger bending the rules of cosmic individuality? First, consider the twin theory. Stars born from the same molecular cloud share nearly identical compositions, like siblings inheriting the same genetic traits. If these two stars formed together, lived similar lives, and reached their demise at nearly the same time, their nebulae could indeed mirror each other down to the last spectral line. But the odds of catching both in this ephemeral phase, a blink in cosmic terms, lasting maybe 50,000 years, are vanishingly small. It's like finding two oak trees in a forest hundreds of miles apart, shedding their leaves in perfect unison on the same autumn day. That's where the light echo hypothesis ignites debate. Imagine a single ancient stellar explosion, a nova or supernova, whose flash illuminated surrounding gas clouds like a cosmic camera flash. The first nebula, the true source, emits its light naturally. The second, a bystander cloud, could echo that light by re-emitting the same wavelengths after absorbing the initial burst. Spectroscopy wouldn't distinguish the original from the echo. Both would glow with matching signatures. The Whirlpool's turbulent arms, rich with shockwaves and radiation fronts, make this scenario eerily plausible. Yet there's a twist in the data. Both nebulae show intricate structures, delicate loops and braids sculpted by stellar winds that light echoes alone can't explain. These formations require active, ongoing energy input from a central star, not a passive reflection. Unless the echo hypothesis includes some bizarre interference pattern, it struggles to account for such fine detail. The most tantalizing clue lies in their motion. If these were unrelated objects, their trajectories through the galaxy would differ. Preliminary measurements, though, hint at parallel movement, as if something propelled them in tandem. Could a long-ago galactic disturbance, like a rogue black hole's passage, have flung both stars into matching orbits before their deaths? Or does the Whirlpool's magnetic web guide dying stars toward synchronized fates? For now, these twin nebulae remain a riddle wrapped in stardust. Whether they're true siblings, optical illusions, or evidence of forces we've yet to name, one thing's certain. In a galaxy where uniqueness reigns, their symmetry feels like a wink from the cosmos, a reminder that even in chaos patterns await. In the Whirlpool Galaxy's graveyard of dead stars, one refuses to stay dead, a cosmic Lazarus that has cheated stellar annihilation not once but multiple times. Astronomers have nicknamed it the zombie star, a white dwarf that exhibits the unmistakable scars of repeated explosions, each blast violent enough to tear an ordinary star apart, yet somehow this one keeps stitching itself back together. It's the astrophysical equivalent of a horror movie villain that just won't stay down, and its very existence forces us to rewrite the rules of stellar death. At first glance, this star's survival defies all logic. White dwarfs, the dense, Earth-sized cores left behind when stars like our Sun exhaust their fuel, are supposed to meet one of two fates: fade quietly into darkness or detonate catastrophically as Type 1a supernova. But the zombie star chose a third option, a series of micro-explosions, each one ripping off layers of material while leaving the core intact. Think of a firework that fizzles instead of detonating, then recharges itself to burst again years later. Spectroscopic data reveals a chaotic shell of ejected material around the star, stacked like onion skins from multiple violent outbursts. So how does a star pull off this resurrection act? The leading theory involves an unstable dance with a hidden companion. If the white dwarf orbits close enough to another star, it could be siphoning hydrogen from its partner's outer layers. Over time, this stolen fuel builds up on the dwarf's surface until pressure and heat trigger a runaway thermonuclear reaction, a mini supernova. Normally, this would obliterate the star entirely, but if the explosion is just weak enough, it might eject only the outer shell, leaving the core to repeat the cycle when fresh hydrogen accumulates. It's like a bomb with a faulty trigger, detonating prematurely yet never fully destroying its mechanism. Then there's the dark horse explanation: exotic matter. Some theorists speculate that under extreme pressures, the star's core might contain strange quarks, hypothetical particles that could stabilize the dwarf against total collapse. If true, this would mean the zombie star isn't just defying death. It's doing so by tapping into states of matter that shouldn't exist in nature. Picture a building surviving earthquakes because its steel beams secretly morph into something unshatterable mid-collapse. But the real enigma isn't just how this star survives. It's why we've found so few like it. If white dwarfs can endure repeated eruptions, where are all the others? The Whirlpool's zombie star might be a fluke, a cosmic one-off where conditions aligned perfectly to create the ultimate stellar survivor. Or perhaps we've been misinterpreting supernova signals for decades, mistaking similar failed eruptions for true stellar deaths. Every flicker from this undead star forces us to question: how many other celestial ghosts are hiding in plain sight, masquerading as ordinary corpses while secretly plotting their next explosion? For now, the zombie star lingers in the Whirlpool's depths, a cryptic testament to stellar resilience. Whether it's a product of binary theft, new physics, or sheer cosmic luck, one thing's certain: in a galaxy teeming with mysteries, even death isn't always what it seems. And as long as this star keeps resurrecting itself, astronomers will keep watching, half in awe, half in dread, for its next act of defiance. Hidden from visible light but blazing in the infrared, a monstrous dark vortex churns silently in the Whirlpool Galaxy's spiral arms, a swirling void so cold and dense it swallows nearly all radiation passing through. Unlike the galaxy's glowing nebulae or glittering star clusters, this anomaly reveals itself only as a shadowy fingerprint in thermal imaging, a cosmic whirlpool within a whirlpool that defies easy explanation. Is it a collapsing gas cloud on the brink of stellar birth, or the silhouette of something far more enigmatic lurking just out of sight? The vortex's sheer scale is the first clue to its strangeness. Spanning over 200 light-years, it dwarfs any known star-forming region in our own galaxy. Yet instead of glowing with the heat of young stars, it radiates a frigid -260 degrees Celsius, mere degrees above absolute zero. Such extreme cold suggests a molecular cloud so dense it blocks even its own thermal emissions, a celestial freezer where gas and dust have pooled into a gravitational sinkhole. Ordinarily, clouds like this fragment into stars, but the vortex's smooth, coherent structure hints at something suppressing that process. Magnetic fields might be strangling it, their invisible threads weaving a cage that prevents collapse. Or perhaps turbulence within the cloud is stirring it too violently, like a whirlpool that churns so fast it never spills over. But there's a haunting alternative. This might not be a cloud at all. The vortex's near-perfect spiral shape bears an uncanny resemblance to shadows cast by protoplanetary disks, those pancake-like rings of debris where planets form around young stars. If a massive, edge-on disk orbits a star at the vortex's heart, its silhouette could stretch across light years when backlit by the galaxy's glow. The problem: no known star could host a disk this colossal unless it belonged to something far more exotic, a rogue black hole perhaps wrapped in a cloak of stolen gas. Simulations show such objects could drag entire nebulae into swirling orbits, creating shadows that mimic cosmic weather patterns. The most tantalizing evidence, though, comes from motion. Over 5 years of observations, the vortex has drifted slightly against the backdrop of stars, as if tugged by an unseen anchor. If it were merely a static gas cloud, galactic rotation should carry it uniformly with its surroundings. This errant movement fuels speculation about a hidden compact object, a neutron star or black hole, plowing through the interstellar medium like a ship trailing a wake. Yet even that theory stumbles when confronted with the vortex's intricate internal structure. Submillimeter telescopes have detected finer spirals within it, braided like rope, a level of detail no wandering object should produce. For now, the infrared vortex remains a study in contradictions, too cold to be active, too structured to be accidental, and too massive to fit known models. Whether it's a stellar nursery frozen in time, the shadow of a cosmic leviathan, or something entirely new, its darkness challenges our understanding of how galaxies sculpt their raw materials. And in a universe that often shouts its secrets, this silent whirlpool reminds us that some mysteries only whisper, in wavelengths hidden to human eyes. Stretching across the void between the Whirlpool Galaxy and its smaller companion, NGC 5195, an almost invisible thread of gamma rays pulses with quiet intensity. This faint bridge, detectable only by the most sensitive space telescopes, defies the usual rules of galactic interactions. Most galaxies linked by gravity exchange stars and gas, fleeting, visible streams of matter. But this connection hums with something far more elusive: high-energy photons flung across 25,000 light-years of near-nothingness. What cosmic forces could forge such a delicate yet powerful link between these dancing giants? One possibility lies in the realm of cosmic rays, subatomic particles accelerated to nearly light speed by supernova explosions or black hole jets. If these particles spiral along magnetic field lines connecting the two galaxies, their collisions with stray atoms could generate gamma rays as a byproduct. Picture a highway of invisible particles shuttling between the galaxies, their head-on crashes sparking bursts of light too feeble to see with the naked eye, yet collectively weaving this ethereal bridge. The whirlpool's turbulent arms, rich with stellar explosions, could serve as particle accelerators on a galactic scale, while NGC 5195's gravity funnels them into this ghostly pathway. Yet there's an even more exotic contender: dark matter. If the invisible halos of these galaxies overlap, their dark matter particles might occasionally annihilate upon contact, releasing gamma rays in the process. Simulations suggest such interactions would be rare, but over millions of years they could leave behind this faint, glowing trail, a cosmic breadcrumb hinting at the universe's most mysterious substance. The bridge's symmetry supports this idea. Its smooth, consistent glow lacks the clumpy irregularities expected from cosmic ray activity. It's as if something invisible is painting the sky with precise, patient strokes. The plot thickens when examining the bridge's structure. Unlike the chaotic tendrils of gas stretching between the galaxies, this gamma-ray pathway shows odd kinks, sharp bends that mirror fluctuations in the Whirlpool's magnetic field. Some researchers propose a hybrid explanation. Dark matter annihilation might seed the bridge, while magnetic fields sculpt its shape, guiding particles like rivers carving a canyon. If true, this ribbon of light could be a Rosetta Stone for two of astrophysics' greatest puzzles: cosmic ray propagation and dark matter's hidden behavior. But the most tantalizing clue lies in the bridge's flickers. Over a decade of observations, its gamma-ray output has waxed and waned unpredictably. Some months, it brightens by a barely perceptible fraction, as if something unseen is periodically stoking its fire. Could NGC 5195's recent gravitational tugs be compressing dark matter density, sparking waves of annihilation? Or are we witnessing the aftermath of a long-ago stellar cataclysm, its shockwaves still rippling through this fragile connection? For now, the bridge remains a whisper in gamma rays, a silent testament to the invisible bonds weaving galaxies together. Whether it's fueled by particles, dark matter, or something beyond our current physics, one thing's certain: in the Whirlpool's grand dance, even the spaces between stars hum with secrets. Deep in the Whirlpool Galaxy's spiral arms, a cosmic metronome has lost its rhythm, a pulsar spinning with such erratic hiccups it's left astronomers scratching their heads. Pulsars, the ultra-dense corpses of massive stars, are nature's most precise clocks, their rotations so regular you could set your watch by them. But this one, catalogued as PSRJ 1235+00, stutters like a broken record. Some days it slows abruptly, as if snagged on an invisible thread. Other times it speeds up without warning, spinning faster like a top flicked by unseen fingers. These glitches aren't just minor fluctuations, they're violent, unpredictable shifts that defy decades of neutron star physics. The first suspect: asteroid impacts. Pulsars often dwell in chaotic graveyards of stellar debris, and a stray space rock the size of a mountain slamming into its surface could deliver enough torque to alter its spin. Imagine a pebble tossed into a spinning bicycle wheel. The disruption wouldn't stop the wheel, but it'd send vibrations rippling through the spokes. Here, the spokes are the pulsar's crust, a crystalline lattice of neutrons harder than diamond. If an impact fractures this surface, the star's outer layers might momentarily decouple from its superfluid core, causing the entire system to shudder. Telescopes have even spotted a dusty disk encircling PSRJ 1235+00, a potential feeding ground for such catastrophic collisions, yet the timing doesn't quite fit. Impact-induced glitches should taper off as debris clears, but this pulsar's anomalies persist, flaring up long after its surroundings should have been sterile. That's led researchers to a more exotic explanation: magnetic reconfiguration. Neutron stars host the universe's strongest magnetic fields, trillions of times more powerful than Earth. If these fields suddenly shift like tectonic plates snapping into new positions, they could twist the star's interior, transferring angular momentum between layers. Picture a figure skater pulling her arms in to spin faster, except here, the arms are magnetic loops rearranging themselves deep within the star's quantum soup core. Spectroscopic hints support this. The pulsar's X-ray bursts often coincide with its spin changes, suggesting magnetic turmoil is at play. But the wildest theory involves an unseen dance partner. PSRJ 1235+00's trajectory shows subtle deviations, as if something massive but invisible tugs on it periodically. Could a rogue black hole or dark matter clump be orbiting just outside detection, its gravity yanking the pulsar off kilter. Simulations suggest such an object wouldn't need to be large. A black hole with the mass of Jupiter could hide in the pulsar's blind spot, its gravitational nudges explaining both the timing and violence of the glitches. It's a cosmic game of hide and seek where the hider warps the very fabric of space. What makes this pulsar truly extraordinary is its refusal to conform. Most glitching pulsars settle into predictable patterns over time, their spasms becoming textbook case studies. PSRJ 1235+00, though, thrives on chaos, its misbehavior a living laboratory for extreme physics. With every erratic pulse, it challenges our understanding of how matter behaves under conditions impossible to replicate on Earth, and proves that even the universe's most precise clocks can sometimes lose track of time. Amidst the Whirlpool Galaxy's star-studded arms, astronomers have stumbled upon a celestial anomaly, a vast region where the universe's chemical clock appears frozen in time. Dubbed the Metal Desert, this expanse spans hundreds of light years with stars so devoid of heavy elements they resemble relics from the cosmos' infancy. In a galaxy where stellar generations typically pepper space with forged metals like iron and silicon, this pocket lingers as a barren wasteland, its chemistry untouched by the alchemy of dying stars. How could such a primordial bubble survive untouched in a galaxy otherwise rich with stellar pollution? One compelling explanation points to a recent galactic heist. The Whirlpool's gravitational tug-of-war with its companion, NGC 5195, may have ripped a dwarf galaxy apart, scattering its pristine gas across M51 spiral arms. Unlike mature galaxies, these cosmic minnows often harbor gas barely enriched by supernova leftover fuel from the early universe. If such a dwarf was shredded mid-collision, its unprocessed hydrogen and helium could have pooled into this desert, diluting the surrounding metallicity like rainwater flushing salt from soil. Radio telescopes have detected faint streams of gas arcing toward the region, their trajectories tracing back to the Whirlpool's turbulent outer halo, a ghostly trail of the crime scene. Yet there's a twist: the desert stars aren't all ancient. Spectra reveal a handful of youthful blue stars blazing within the void, their presence defying expectations. Metal-poor environments lack the dust required to cool gas clouds and trigger star birth, making these hot young outliers cosmic contradictions. One theory suggests they formed from shockwaves, violent pressure fronts from nearby supernovas or galactic collisions that compressed even primitive gas into stellar embryos. Picture a wildfire igniting in a rainforest. These stars are the paradoxical flames flickering in a chemical ice age. The desert's true enigma, though, lies in its borders. Unlike typical low-metal zones that blend gradually into richer regions, this one ends abruptly, as if walled off by invisible forces. Some researchers suspect magnetic fields act as cosmic dams, trapping primordial gas within while metal-enriched flows detour around it. Others propose a darker architect, a rogue concentration of dark matter, its gravity sculpting the gas like an unseen hand pressing down on taffy. Whatever the cause, this alien enclave offers a rare window into the universe's raw, unprocessed beginnings. It's a place where the Whirlpool's usual rules of chemical evolution don't apply, and where every atom whispers secrets about how galaxies grow, steal, and sometimes preserve the past against all odds. Buried in the Kepler Space Telescope's observations of the Whirlpool Galaxy lies a celestial paradox: planets orbiting stars that shouldn't exist. These aren't just any worlds, they're gas giants the size of Jupiter, clinging to stellar corpses or blazing paths around stars too young or too chaotic to host such orderly systems. At first glance, the data seems irrefutable. Rhythmic dips in starlight, the telltale signature of planets transiting their suns, but peer closer and the picture unravels. The stars these worlds supposedly circle neutron stars spinning wildly. blue supergiants barely out of their stellar cradles defy every model of planetary formation. So are we witnessing detection errors, cosmic mirages, or something far stranger? One explanation cuts through the noise: rogue planet capture. The Whirlpool's violent gravitational tides, stirred by its dance with NGC 5195, could be flinging free-floating planets across the galaxy like cosmic pinballs. These orphan worlds, born around stable stars before being ejected by gravitational chaos, might later stumble into new orbits around unlikely hosts. Picture a drifter snatched from the streets and thrust into a mansion. It doesn't belong there, but by sheer chance, it's home now. Computer simulations show such captures are rare but plausible, especially in galaxies like the Whirlpool where stellar densities run high. A gas giant wandering too close to a neutron star's gravity well could be trapped, its orbit stabilized by the corpse star's fierce pull. Yet some of these planetary candidates orbit stars so young they haven't finished forming themselves. Protostars swaddled in natal gas clouds shouldn't yet have cleared debris disks dense enough to birth Jupiters, yet Kepler's data insists they do. Here, the culprit might be illusion, not planets at all, but clumps of dust spiraling inward as the star consumes its birth cloud. These swirling masses can mimic planetary transits, their uneven shapes creating flickers indistinguishable from a gas giant's silhouette. It's like mistaking a flock of birds for a single aircraft. From afar, the patterns deceive. The plot thickens with pulsar planets, worlds circling dead stars that died in supernova violent enough to vaporize any original planetary system. Yet the Whirlpool hosts at least 3 such claims. One leading theory suggests second-generation planets after the supernova falling debris, a mix of stellar ashes and interstellar material, could coalesce into new worlds from the ashes of the old. Imagine a phoenix not just rising from its own wreckage, but knitting that wreckage into eggs. These would be planets born from death, their chemistry laced with heavy elements forged in their star's dying breath. But the most tantalizing possibility, we're seeing shadows cast by objects our physics can't yet classify. Some planetary signals in the Whirlpool pulse erratically, their transit depths varying wildly between orbits. Could these be failed stars, black hole binaries, or even dark matter structures warping spacetime in ways that mimic planets? Until we peer deeper, these invisible worlds will linger at the edge of understanding, whispering that even in a galaxy mapped by telescopes, some mysteries refuse to be catalogued. High above the Whirlpool Galaxy's spiral disk, a cosmic storm rages, an invisible fountain of particles blasting into intergalactic space with energies that dwarf anything humanity's most powerful atom smashers can produce. These aren't just ordinary cosmic rays. They're ultra-high-energy protons and atomic nuclei traveling at nearly light speed, each carrying the punch of a major league fastball compressed into a single subatomic speck. Their source, a mysterious region in the Whirlpool's outer arms where the laws of physics seem to redline, turning a seemingly quiet patch of stars into the galaxy's most powerful particle accelerator. What makes this cosmic ray fountain so baffling is its pinpoint intensity. Normally, such extreme particle energies come from sprawling sources, supernova remnants stretching dozens of light years, or active galactic cores with jets spanning thousands. But here, the most violent cosmic rays appear to originate from a shockingly compact zone barely larger than our solar system. One explanation points to microquasars, stellar mass black holes, or neutron stars with accretion disks so frenzied they mimic miniature versions of their supermassive cousins. Imagine a hurricane spinning inside a teacup. These tiny dynamos could be whipping particles to absurd energies through magnetic chaos and relativistic jets, then firing them into the void like bullets from a cosmic gun. Yet there's a problem with this neat theory. Some of the particles beam outward with energies that even microquasars shouldn't achieve. That's led researchers to consider darker architects like annihilating dark matter. If certain hypothetical particles, say WIMP, weakly interacting massive particles, cluster densely in this region, their collisions could unleash cascades of ordinary matter and energy. Picture two invisible icebergs smashing together underwater, their impact sending visible spray arcing into the sky. The Whirlpool's twisted dark matter halo, stirred by its companion galaxy, might naturally funnel these particles into collision zones, creating sporadic but unimaginably powerful bursts. The plot thickens when examining the fountain's rhythm. Unlike steady cosmic ray sources, this one sputters, flooding space with particles for weeks before falling eerily silent for months. This on-off pattern hints at an object with cycles, like a black hole snacking on material in fits and starts. But the latest data reveals something stranger. When the fountain reactivates, the particles often arrive with a subtle spin polarization, their paths ever so slightly twisted. That's the fingerprint of an intense magnetic field, one that shouldn't exist in such a barren stretch of the galaxy unless something massive is hiding there, warping space itself. For now, this energetic enigma remains a beacon of the unknown. Whether it's a microquasar switching gears, dark matter revealing itself, or something entirely new, one thing's clear. In the Whirlpool Galaxy, even the emptiest corners can hide forces capable of bending the universe's rules to their will. And every particle that rains down from that invisible fountain carries a coded message, one we're just beginning to decipher. Rippling through the Whirlpool Galaxy like a phantom shout in a cosmic canyon, a supernova's light echo lingers long after the star's death cry should have faded into history. This ghostly phenomenon, dubbed the echo supernova, isn't just a delayed reflection, it's a celestial cold case. Telescopes have spotted concentric rings of light expanding outward from a point where no explosion was ever recorded, a puzzle wrapped in the fabric of space-time itself. If this star detonated centuries ago, why didn't a single astronomer on Earth note its brilliant flash? The answer might rewrite how we perceive time, dust, and the quiet violence of the cosmos. To unravel this mystery, we must first understand light echoes. When a supernova explodes, its light radiates in all directions, but not all photons arrive at Earth simultaneously. Some strike interstellar dust clouds, scattering and bouncing off particles before finally reaching us decades or even centuries later. These delayed photons create the illusion of expanding rings, like ripples from a pebble tossed into a pond where the water's surface records the splash long after the stone has sunk. In the Whirlpool's case, these echoes trace back to a region brimming with molecular dust, a cosmic hall of mirrors that's been slowly replaying the explosion's final act. By measuring the echo's angular size and comparing it to the dust cloud's known distance, astronomers have reverse-engineered the supernova's true detonation date, around the year 1745, give or take a decade. That timing alone raises eyebrows. By the mid-18th century, telescopes were advanced enough to spot such events, yet no records from Europe, Asia, or the Islamic world mention a new star in the Whirlpool's direction. The likely culprit, a cosmic curtain call. This supernova might have been a failed spectacle, its light swallowed by the very dust that now reveals its echo. Most supernovas outshine their host galaxies for weeks, but if this one erupted behind an unusually thick dust lane, its visible light could have been almost entirely absorbed, leaving only infrared whispers undetectable to premodern astronomers. Modern simulations support this. When researchers modeled the explosion behind varying dust densities, they found scenarios where 99% of the visible light was extinguished before reaching interstellar space. The Whirlpool's chaotic arms, rich with star-forming regions, could easily hide such an event like a firework bursting behind a smoke screen. Yet there's a tantalizing alternative. The echo might not be a supernova at all. Some researchers speculate it could be the aftermath of a rarer, darker cataclysm, a black hole consuming a white dwarf star. such events produce faint, transient flares rather than the brilliant pyrotechnics of a supernova, leaving little trace beyond scattered light reverberating through dust. The echo's spectral fingerprints, subtle traces of ionized sulfur and oxygen, hint at temperatures and energies that don't perfectly match typical supernova models. It's the difference between finding a charred log and a melted steel beam. Both suggest fire, but of radically different kinds. The most profound implication, though, isn't just about this one event, it's about how many others we've missed. If a stellar explosion can vanish into the void of history, how many more lie hidden in the dusty back alleys of galaxies? The Whirlpool's echo supernova forces us to confront an eerie truth. The cosmos might be far more violent than it appears, its brightest dramas playing out unseen. And every ripple of light echoing across the void is a reminder sometimes the universe's loudest stories are the ones it whispers. At the heart of the Whirlpool Galaxy's core, two black holes spin in a gravitational tango so chaotic it defies all expectations. A binary system locked in orbit yet stubbornly resisting the final merge. These are no ordinary cosmic predators. Their dance is a frenzied, lopsided affair, their paths looping erratically like drunken fireflies rather than the stately spirals physicists predicted. Gravitational wave observatories have been waiting for such pairs to announce their union with a telltale spacetime ripple. Yet this duo keeps teasing detection, circling each other for millennia without surrendering to the inevitable. What cosmic force could possibly stall the universe's most relentless embrace? The first clue lies in their mismatched masses. While most merging black holes are relatively close in size, this pair pits a heavyweight against a lightweight, one 20 times the Sun's mass, the other barely 5. Such an imbalance sends their orbital dynamics into chaos. Think of a waltz between a sumo wrestler and a ballerina. Their movements become unpredictable, with the smaller black hole lunging wildly as the larger one's gravity yanks it off course. Simulations show the lighter object might be trapped in a zoom-whirl pattern, alternating between distant, looping arcs and sudden, tight curls that fling it perilously close to its partner before momentum carries it away again. It's a dance perpetually on the edge of collapse, yet never quite tipping over. But mass alone doesn't explain the delay. Enter the Whirlpool's crowded core, a stellar mosh pit where third parties constantly meddle. Stars, gas clouds, and even other black holes buzz around the binary, their gravitational nudges acting like invisible hands shoving the dancers apart just as they near collision. One theory suggests a stealthy third black hole lurks nearby, its subtle tugs warping the pair's orbit like a hidden puppeteer. Others point to the accretion disks, swirling rivers of gas around each black hole that act as cosmic bumpers, their pressure pushing the duo apart like magnets repelling. Picture two spinning tops dipped in glue. Every time they nearly touch, the sticky resistance flings them backward. The most tantalizing wrinkle, gravitational wave predictions for such a system don't match observations. Normally, black holes on the verge of merging emit a rising chirp, a crescendo of spacetime vibrations. But the Whirlpool's duo hums a dissonant tune, their signal flickering erratically as if someone keeps turning the volume knob. Some astrophysicists argue this could be evidence of floating orbits, a rare state where energy lost to gravitational waves is counterbalanced by energy stolen from the surrounding galaxy's rotation. It's like a pendulum clock that winds itself back up every time it's about to stop. Yet the ultimate irony is this: their refusal to merge might be the very thing that reveals them. Most black hole binaries vanish from our detectors once they collide, their final burst of waves fading into silence. But this prolonged, messy dance broadcasts their presence across the cosmos, offering astronomers front-row seats to a phenomenon that could rewrite our understanding of how black holes court catastrophe. And with every chaotic loop, they whisper a question. In a universe that craves equilibrium, what does it take to keep chaos alive? Among the Whirlpool Galaxy's countless stars, a rare few defy expectation with atmospheres so transparent they border on invisibility. Dubbed glass stars by astronomers, these celestial oddities don't glow with the rich hues of their peers. Instead, their light passes through their outer layers with almost no distortion, as if their very atmospheres were forged from cosmic crystal. Spectroscopic analysis reveals why. Their upper layers are bizarrely depleted of elements like sodium and iron, the very atoms that typically absorb and scatter starlight. The result, a star that shines with unnerving purity, its radiance nearly unaltered from core to cosmos. Theories about their origins range from the elegant to the apocalyptic. One camp argues these stars are cosmic cleansers, born in regions where interstellar clouds were stripped of heavier elements by some ancient cataclysm, perhaps a supernova shockwave that blew away light-blocking contaminants like a stellar pressure washer. Imagine a snowstorm where every flake is filtered until only the clearest ice remains. These stars might have formed from similarly pruned material. Supporting this, several glass stars cluster near the Whirlpool's ghostly hydrogen void, hinting at a shared history of violent purification. But there's a darker twist. Some glass stars show signs of stellar vampirism, their pristine atmospheres marred by faint traces of heavy elements deeper down. This suggests a grisly process. A nearby companion star, rich in metals, might have been cannibalized over eons, its heavier atoms sinking beneath the surface while the predator's upper layers stay paradoxically clear. Picture a lake so still it mirrors the sky perfectly, its surface untouched even as debris rots in the depths below. The most mesmerizing feature, though, isn't their composition, it's their lensing effect. When a glass star passes in front of distant objects, its atmosphere acts like a weak telescope lens, subtly magnifying and distorting the light behind it. Astronomers have used this quirk to map otherwise invisible interstellar clouds, their density revealed by how they bend the star's unusually unimpeded light. It's as if the universe handed us a set of celestial eyeglasses, each flaw in the glass exposing hidden contours of the cosmos, yet the ultimate mystery is time. Glass stars shouldn't last. In most environments, stellar winds and cosmic radiation would eventually pollute their clarity, yet these retain their transparency for billions of years. Some researchers speculate their magnetic fields act as shields, deflecting contaminating particles like an invisible force field. Others propose they're refugees from a vanished dwarf galaxy, their unique chemistry preserving them like insects trapped in amber. Whatever their origin, these crystalline sentinels offer more than just aesthetic wonder. By studying them, we glimpse how galaxies recycle or fail to recycle their elemental building blocks. And in their flawless light, the Whirlpool whispers a lesson. Sometimes the universe's most profound secrets are hidden not in brilliance, but in what doesn't shine at all. Deep in the radio silence between the Whirlpool Galaxy's stars, a whisper loops endlessly, a signal so faint it skirts the edge of detection, pulsing at frequencies lower than a human heartbeat. Unlike the explosive bursts of pulsars or the static hiss of interstellar gas, this emission hums with eerie regularity, a refrain of cosmic white noise that's lingered for decades without fading or shifting. Astronomers first dismissed it as interference, but when 6 separate telescopes from Earth's surface to orbit all traced its origin to the same patch of the Whirlpool's outer arms, the hunt began in earnest. What could produce such a quiet, unyielding radio chant, and why does it defy every known category of astrophysical engine? The leading theory points to plasma oscillations, vast, slow-motion waves rippling through the galaxy's magnetized gas. Picture the Whirlpool's interstellar medium as an ocean, its currents stirred by supernova shocks and stellar winds. Under the right conditions, these disturbances can generate low-frequency resonances like the deep, rhythmic tolling of a bell submerged in water. If dense plasma clouds in the signal's path act as natural amplifiers, they might be stretching weak radio waves into this persistent drone. Supporting this, the whisper's frequency matches predictions for ultra-long wavelength plasma waves, a phenomenon observed in lab experiments but never before confirmed across interstellar space. Yet there's a wrinkle in the plasma theory, the signal's unnatural purity. Natural plasma oscillations typically jitter and warp as they interact with turbulent magnetic fields, their frequencies smearing like a detuned radio. This whisper, though, holds its tone with near mathematical precision, as if filtered through some cosmic synthesizer. That consistency has sparked wilder conjectures. Could it be the echo of a primordial black hole's evaporation, a process theorized to emit low-frequency radiation as these ancient relics dissolve into nothingness? Or perhaps the remnants of a hyper-advanced civilization's power grid, its infrastructure leaking radio waste like a forgotten neon sign flickering in the void. The most compelling clue lies in the whisper's modulation. Detailed analysis reveals barely perceptible pulses, not random, but following a fractal pattern reminiscent of turbulent cascades in fluid dynamics. This hints at a scale-invariant process where energy transfers repeat whether you zoom into atomic scales or out to galactic ones. Some researchers argue this fingerprint points to a previously unknown state of magnetized plasma, one where magnetic reconnection events self-organize into a standing wave. It's like dropping pebbles into a pond at just the right intervals to sustain perfect ripples indefinitely, but the whisper's true enigma may be its location. It emanates from a seemingly unremarkable stretch of the Whirlpool spiral, no star clusters, no supernova remnants, not even a dense molecular cloud. Just ordinary interstellar space humming with extraordinary persistence. If plasma is the culprit, why here? The answer might involve the galaxy's invisible scaffolding. Dark matter distributions or magnetic field loops could be focusing the signal, turning an otherwise faint process into a detectable beacon. Or perhaps we're witnessing the aftermath of a long-gone cataclysm, its shockwaves still reverberating through the interstellar medium like thunder from a storm that passed centuries ago. For now, the whisper remains a riddle written in radio waves, a reminder that even the universe's quietest voices can carry the weight of its deepest secrets. And as telescopes grow more sensitive, who knows what other murmurs we might uncover, hidden beneath the cacophony of stars. Tucked away in the Whirlpool Galaxy's halo, a celestial predator lurks, a globular cluster so massive it bends the rules of cosmic survival. Unlike most clusters which drift through space like peaceful stellar islands, this one devours its neighbors whole, growing fat on stolen stars. Astronomers call it the cannibal cluster, a gravitational titan that spent millions of years tearing apart smaller clusters and stitching their stars into its own spiraling fabric. The result, a stellar Frankenstein, an assembly of stars with wildly different ages, chemistries, and orbits, all bound together by an insatiable appetite for destruction. What makes this cluster unique isn't just its violence, it's the forensic evidence left behind. High-resolution imaging reveals tidal streams, ribbons of stars stretching far beyond the cluster's core, the shredded remains of its latest meal. These stellar rivers curve like the spines of shattered galaxies, tracing the paths of doomed clusters as they spiraled inward. Some streams are so fresh they still pulse with blue, young stars, while others fade into ghosts of ancient mergers, their origins nearly erased by time. It's a galactic crime scene where the victims' remnants are still glowing. Simulations of the cannibal cluster's feeding frenzy reveal a brutal dance of gravity. When a smaller cluster wanders too close, tidal forces stretch it like taffy, pulling stars loose in opposing directions. Some escape entirely, flung into the whirlpool's halo as cosmic runaways. But most are captured, their orbits rewritten by the cannibal's overwhelming pull. Over centuries, these captured stars settle into chaotic new paths, swirling in patterns that defy the orderly orbits of stars born in the cluster naturally. Picture a crowded ballroom where half the dancers move in elegant waltzes while the others stumble in drunken spirals. still disoriented from being dragged onto the floor mid-song. The most fascinating clue lies in the cluster's chemical diversity. Most globular clusters are homogeneous stars forged from the same primordial gas, sharing nearly identical compositions. But here, spectroscopy unveils stark divides pockets of metal-rich stars nestled beside ancient metal-poor ones, like strangers from different continents forced into the same city. These mismatched groups betray the cluster's history of theft, each stellar population a relic of a different victim absorbed over time, yet the cannibal cluster's most unsettling feature. It's still hungry. Observations show fresh streams of stars spiraling toward it, their trajectories warped by its pull. The Whirlpool's tides funnel these doomed clusters into its path, ensuring the feast never ends. And with every merger, the predator grows not just in size but in complexity. Its core now hosts black holes and neutron stars stolen from its prey, turning it into a graveyard of galactic violence. One day, this cluster may grow so massive it collapses under its own weight, a rogue superstructure devouring itself. But for now, it spins on, a monument to the chaos lurking beneath the Whirlpool's beauty. And in its swirling depths, we see a truth written in starlight. Even in the vastness of space, nothing escapes the pull of hunger forever. In the Whirlpool Galaxy's bustling stellar neighborhood, one star ticks slower than the universe allows, a Cepheids variable whose rhythmic pulses stretch like taffy over time, defying every known law of stellar mechanics. Cepheids are normally the cosmos' most reliable metronomes, their brightness waxing and waning with clockwork precision as their outer layers expand and contract. But this one, catalogued as VX51, has been caught red-handed in an act of temporal rebellion. Its pulses, once steady at 12-day intervals, now lumber along at 14 days and show no signs of stopping their slowdown. Is this star bending time itself, or are we witnessing something even stranger masquerading as physics gone rogue? The first suspect, space-time curvature. Einstein's theory of relativity tells us massive objects warp the fabric of reality, stretching time like a rubber sheet. If VX51 orbits an unseen black hole or neutron star, the resulting gravitational time dilation could make its pulses appear slower to outside observers, like a clock ticking sluggishly near a black hole's edge. But here's the catch: the slowdown isn't constant. Instead, it accelerates in fits and starts, as if whatever's warping time keeps shifting its grip. That rules out a simple, stable orbit. Some theorists suggest the culprit might be a wandering intermediate mass black hole, an elusive cosmic middleweight drifting nearby and flexing its gravitational muscle unpredictably. Picture a moth fluttering around a flickering street lamp. Its shadow stretches and shrinks erratically, even if the light itself stays steady. Then there's the stellar evolution angle. Cepheids pulse because of a delicate balance between radiation pressure and gravity in their helium-rich outer layers. If VX51 is undergoing internal changes, perhaps mixing fresh hydrogen into its pulsation zone or developing abnormal magnetic fields that could artificially stretch its cycle. Observations reveal faint traces of carbon monoxide in its atmosphere, a possible sign of deep convection dredging up material from the core. It's as if the star's engine is choking on its own exhaust, each pulse laboring harder than the last. But the most bewildering possibility is observational sabotage. The Whirlpool Galaxy's dusty spiral arms might be playing tricks on us. If dense clouds of interstellar dust drift between VX51 and Earth, they could selectively absorb shorter wavelength light during the star's bright phase, making its peaks appear dimmer and more drawn out, like listening to a song through a wall that muffles the high notes. Recent infrared studies compound the mystery. While visible light shows the slowdown, infrared pulses less affected by dust remain steady. This suggests two realities happening at once, a star behaving normally in one wavelength while seemingly bending time in another. Yet even this explanation frays at the edges. If dust were the villain, other Cepheids nearby should show similar distortions. Instead, VX51 stands alone. Its time-warped pulses a riddle without a clear parallel. Some astronomers whisper about more exotic causes, a collision with a dark matter clump, perhaps, or a temporary entanglement with some unseen quantum field. Others propose that the star's pulsations are literally resonating with spacetime itself, its vibrations tapping into the universe's hidden harmonics like a tuning fork pressed against a drumhead. For now, VX51's sluggish ticks remain a cosmic stutter, a challenge to our understanding of how stars live, pulse, and sometimes slip the bonds of time. Whether it's a sign of hidden monsters, stellar illness, or celestial illusion, one thing's certain. In the Whirlpool Galaxy, even the steadiest rhythms can falter, leaving us to wonder what strange forces conduct the orchestra. Floating in the Whirlpool Galaxy's star-flecked tapestry, an eerie cosmic bubble glows softly, the Hollow Nebula. Unlike typical nebulae with their chaotic swirls of gas and dust, this one presents a perfect spherical emptiness at its core, as if some celestial hand scooped out its heart. The nebula's outer shell shimmers with delicate filaments of ionized hydrogen and oxygen, lit from within by young, hot stars, but step by step toward the center, the glow fades until nothing remains but a chilling dark sphere, a void within the light. What force could carve such a precise pocket of nothingness in the midst of a stellar nursery? The leading explanation points to stellar winds, the hurricane-like outflows from massive stars. Imagine a candle burning inside a soap bubble. The heat pushes the soap film outward, creating a hollow center. In this case, the candle is a cluster of O-type stars, each blasting space with charged particles at millions of miles per hour. Their combined ferocity could have blown away the nebula's innermost gas over millennia, sculpting this strange, empty chamber. Supporting this, infrared telescopes detect faint shockwaves rippling through the nebula's shell, ghostly echoes of ancient stellar tempests. But there's a twist. The hollow isn't perfectly centered. Off to one side, a dense knot of gas pulses with residual heat, as if something violent happened there long ago. This asymmetry fuels an alternate theory, a binary star explosion. If two massive stars once orbited at the nebula's core, their dance could have ended catastrophically when one went supernova. The blast might have ejected their shared gas envelope unevenly, like a grenade detonating near the edge of a balloon. The surviving companion, now a rogue star hurtling through space, could be the missing sculptor, its gravity and the explosion's shockwave conspiring to leave this lopsided void. The most tantalizing clue, though, lurks in the hollow silence. Most stellar wind-carved bubbles emit faint radio waves from heated gas, but this one's core is eerily quiet. Some researchers speculate the void isn't entirely empty. It might house a stealthy black hole or neutron star, its intense gravity trapping nearby particles too tightly for them to emit detectable radiation. Others propose that exotic molecules formed in the explosion's aftermath, their unique chemistry absorbing energy rather than re-emitting it. It's like finding a room where sound vanishes the instant it's made, a cosmic echoic chamber forged by forces we barely understand. What makes the Hollow Nebula truly extraordinary isn't just its emptiness, it's what that emptiness reveals about stellar violence and artistry. Whether shaped by winds, explosions, or hidden monsters, this celestial soap bubble stands as a testament to the whirlpool's endless capacity for wonder. And in its silent heart, it poses a question. Sometimes is absence the most powerful presence of all? Deep within the Whirlpool Galaxy's spiral arms, a dead star sings, not in light or radiation, but in pulsing radio waves that rise and fall like notes in a cosmic symphony. This is no ordinary neutron star. It's a magnetar, one of the universe's most extreme objects, with a magnetic field so powerful it could strip the electrons from your atoms from halfway across the solar system. But what makes this one extraordinary isn't just its strength. It's the eerie rhythm of its emissions, a cadence so precise it resembles music. Dubbed the singing magnetar, this stellar corpse broadcasts pulses that fluctuate in pitch and tempo, as if some unseen hand were plucking the strings of spacetime itself. The melody, though, isn't born from artistry, it's forged in violence. Magnetars are already known for their tantrums. Their crusts, frozen under unimaginable pressure, occasionally fracture in starquakes, releasing energy equivalent to 1 billion nuclear bombs. But this one's oscillations suggest something even stranger. Vibrations rippling through its magnetosphere, the labyrinth of magnetic field lines that encase it like a cage. Picture plucking a guitar string, except here, the string is a loop of magnetic force trillions of times stronger than Earth's field, and the pluck is a crustquake shuddering through the star's crystalline surface. Each tremor sends waves racing along these magnetic ropes, their frequencies shifting as they interact with superheated plasma trapped in the field's grip. The result, a celestial feedback loop where every quake begets a chorus of radio pulses, their pitch revealing the magnetar's hidden structure, yet the song isn't static. Over months of observation, astronomers noticed subtle drifts in the magnetar's voice notes slowing or speeding up unpredictably. Some theorize this stems from the star's crust slowly rearranging itself, its tectonic plates of neutron-rich matter sliding and cracking under magnetic strain. Others point to external meddling. A nearby black hole or dense debris disk could be warping the magnetosphere's shape, altering its resonant frequencies like a finger pressing on a guitar's fretboard. The most tantalizing clue, brief staccato bursts that interrupt the rhythm, akin to a record skipping. These might be magnetic reconnection events, snapping field lines releasing energy in chaotic spasms, a reminder that even in this ordered chorus, chaos lurks beneath. What makes this magnetar's song so invaluable isn't just its strangeness, it's the secrets it unveils. By decoding its pulses, astronomers can map the star's interior as clearly as a doctor reading an ultrasound. The lower notes hint at the crust's depth, while the higher frequencies trace the magnetosphere's outermost loops. And in the silences between pulses, we might even detect the faint echoes of exotic physics, quantum vibrations in the star's hypothetical core of free quarks, or the groan of spacetime itself bending under the magnetar's weight. For now, the singing magnetar serenades the void, its radio aria a testament to the Whirlpool's boundless ability to turn destruction into beauty. And with every pulse, it asks us to listen closer, because in this galaxy, even the screams of the dead can be rearranged into song. In the heart of the Whirlpool Galaxy's spiral arms lies a cosmic contradiction, a stellar nursery where stars ignite in near-total darkness. This region, catalogued as DSFR1, defies all expectations by radiating newborn starlight while showing almost none of the glowing gas clouds that typically accompany star birth. It's as if the galaxy is hosting a fireworks show in a pitch-black arena, the explosions visible but their launching pads mysteriously absent. How can stars form without the telltale glow of ionized hydrogen or the dusty cocoons we've come to associate with their creation? The answer might rewrite our playbook for how galaxies assemble their stellar populations. The most plausible explanation hides in the shadows, literally. Astronomers suspect this region is swaddled in dark molecular clouds, dense knots of gas so thick with dust they block nearly all visible light from escaping. Unlike typical nebulae that fluoresce when bombarded by starlight, these cosmic vaults absorb radiation completely, converting it into infrared wavelengths invisible to optical telescopes. Imagine a fog so dense it smothers a lantern's glow, except here, the fog is light years wide and the lanterns are massive young stars. Supporting this, infrared observations reveal seething heat behind the veil, with protostars detected in various stages of formation, their warmth betraying the otherwise invisible nursery. But there's a catch. Even the darkest molecular clouds usually emit faint radio waves as their hydrogen molecules jostle against one another. DSFR-1 radio silence hints at something stranger, a cloud composition laced with exotic ices or complex carbon chains that dampen emissions across multiple wavelengths. Laboratory experiments with interstellar ice analogues suggest such mixtures could exist, their structures absorbing and redistributing energy in ways that leave the cloud stealthy to conventional detection. It's like trying to spot a black cat in a coal mine, not impossible, but requiring tools beyond standard flashlights. The wild card, these might not be clouds at all. A radical theory posits that DSFR-1 could be a graveyard of failed stars, brown dwarfs, or rogue planets stripped of their atmospheres by some ancient cataclysm. Their remaining cores, too cold to shine but still massive enough to collapse under gravity, might be sparking sporadic star formation through collisions or gravitational instability. Picture a dimly lit match factory where occasional friction ignites a flare, except the matches are stellar remnants and the factory spans interstellar space. What makes this dark nursery truly unsettling is its longevity. Star-forming regions usually dissipate within a few million years as stellar winds blow away their birth clouds. Yet DSFR-1 persists, its star birth continuing unabated as if shielded from time itself. Some researchers speculate the Whirlpool's unique magnetic fields could be cocooning the region, their invisible lines acting like cosmic rains that keep the gas from escaping. Others wonder if we're witnessing the aftermath of a galactic collision, where a passing dwarf galaxy dumped fresh, opaque gas into this pocket like a cosmic ink blot. The implications ripple far beyond this one anomaly. If dark star-forming regions are common, we might be missing entire generations of stellar births in galaxies across the universe. Infrared telescopes like JWST are now peering into these shadows, revealing how much of the cosmic story has been hidden in plain sight. And in the Whirlpool's silent nursery, every invisible gas clot and every unseen protostar whispers a humbling truth. Sometimes, the universe's most vibrant creations emerge from its darkest corners. Among the Whirlpool Galaxy's countless stars, astronomers have stumbled upon a behavior so strange it bends our understanding of light itself. Stars whose brightness doesn't just flicker, but fluctuates with impossible precision, as if their photons are obeying quantum rules on a cosmic scale. These quantum light curves don't follow the predictable dips and surges of pulsating variables or eclipsing binaries. Instead, their luminosity dances in discrete, staircase-like steps, like a cosmic dimmer switch clicking between set brightness levels rather than sliding smoothly. It's a phenomenon that shouldn't exist unless something fundamental about how light travels through interstellar space isn't what we thought. The first suspect is the Whirlpool's turbulent atmosphere, not of planets but of the galaxy itself. Stars twinkle from Earth's perspective because our atmosphere scatters their light, but on an interstellar scale, similar distortions could arise from patches of dense plasma or magnetized gas between us and these stars. Picture sunlight filtering through a frosted glass pane. The pane isn't uniformly cloudy, so the light lands in uneven patches. If the Whirlpool's spiral arms contain lenses of ionized material with specific densities, they might act like cosmic prisms, quantizing starlight into distinct brightness bands as photons are selectively absorbed or amplified. Telescopes have spotted hints of this in radio wavelengths, where certain regions of the galaxy's interstellar medium pulse with rhythmic electron density fluctuations, like invisible tidal forces squeezing and stretching the fabric of space itself. Yet there's a wrinkle that makes this explanation itch. Some of these quantum steps occur faster than light should physically traverse the proposed distorting structures. Unless these plasma patches are moving at relativistic speeds unlikely without visible jet activity, the timing defies conventional scattering models. That's led theorists to consider wilder possibilities like vacuum polarization. Quantum field theory suggests that empty space isn't truly empty. It's a seething foam of virtual particles that pop in and out of existence. Under extreme magnetic fields like those near neutron stars or black holes, these virtual particles could theoretically align in ways that polarize passing light, effectively filtering it into discrete intensity levels. It's as if starlight is passing through a cosmic colander, with only certain photon sizes making it through the holes. The most tantalizing data, though, comes from stars exhibiting entangled light curves, pairs of stars light years apart whose quantum steps sync up perfectly despite no known physical connection. This eerie coordination mirrors quantum entanglement in lab experiments, where particles instantly influence each other across distances. Of course, stars can't be quantum entangled in the traditional sense, but their light might be interacting with a shared medium, perhaps a network of dark matter filaments or a primordial field left over from the galaxy's formation. Some models even speculate about topological defects in space-time, relics of the early universe where the cosmic fabric is knotted like a tangled shoelace, leaving imprints on any light passing through. For now, these quantum light curves remain a celestial cipher, one that could either reveal hidden layers of interstellar physics or force us to reconsider how light behaves across galactic distances. Every flicker, every step-like pulse is a breadcrumb on the path to understanding whether we're seeing the whirlpool's hidden structures or the universe quietly rewriting its own rules. Deep within the Whirlpool Galaxy's spiral arms, astronomers have uncovered planetary systems that seem to mock the universe's love of chaos, twin star systems hosting exoplanet arrangements so identical they border on cosmic plagiarism. These mirror systems, separated by hundreds of light years, each boast the same improbable lineup: an inner rocky world followed by two gas giants in resonant orbits capped by an icy outlier. The odds of such duplication occurring by chance are astronomically low, raising profound questions about whether we're witnessing unseen forces shaping planetary births or the subtle biases of our own telescopes. The first pair of mirror systems, catalogued as M51 EP41 and EP42, initially appeared ordinary. But when researchers mapped their exoplanets using transit and radial velocity data, an eerie pattern emerged. Both systems feature a super-Earth precisely 3 times Earth's mass orbiting at 0, 4 astronomical units, 2 hot Jupiters locked in a 3:2 orbital resonance, and a distant mini-Neptune with a 45-degree axial tilt. Such specific matching suggests either a shared blueprint for planet formation or an observational illusion. One compelling theory points to migration traps, regions in protoplanetary disks where gas density and temperature create gravitational sweet spots that funnel forming planets into predictable orbits. If both systems formed from molecular clouds with nearly identical conditions, their planetary architectures might have converged like snowflakes crystallizing in the same storm. Yet skeptics argue we're falling victim to selection bias. The Whirlpool's dense star fields make it ideal for detecting certain planet types. Hot Jupiters transit frequently, while large rocky worlds create clear Doppler wobbles in their host stars. Smaller or more distant planets might be hiding in both systems, their absence in the data creating artificial symmetry. It's like judging two forests identical because you only spotted the tallest trees from a distance. Advanced modeling reveals a sobering truth. If EP41 and EP42 actually host additional unseen planets in divergent orbits, their mirror effect could shatter like glass. The most tantalizing clue lies in their chemistry. Spectroscopic analysis of both host stars shows matching overabundances of titanium and yttrium metals known to influence planet formation. This hints they might be long-lost stellar siblings, born from the same gas cloud before drifting apart. If true, their planetary twins could be fossils of shared origins, like identical pottery shards from a shattered ancient vase. Supporting this, dynamical simulations suggest the system's current orbits would require nearly identical initial conditions 10 billion years ago, a scenario more plausible if they formed together. But the true enigma emerges when comparing their timelines. EP41 star is a youthful 2 billion years old, while EP42 is a senior citizen at 7 billion. If they're unrelated, how did their planets arrange themselves so similarly across such vast stretches of time? One radical hypothesis proposes that galactic-scale magnetic fields or dark matter filaments could act as invisible sculptors, guiding planetesimals into preferred configurations regardless of era. Imagine two painters separated by centuries unknowingly duplicating a masterpiece because their brushes were magnetized to the same unseen template. As telescopes like JWST peer deeper, these mirror systems force us to confront a humbling possibility. What we consider cosmic chaos might be threaded with hidden order. Whether through shared origins, detection blind spots, or forces beyond our current physics, the Whirlpool's planetary doppelgangers remind us that even in a galaxy of infinite variety, patterns sometimes repeat, like a universe whispering its secrets in twin tongues. In the Whirlpool Galaxy's outer reaches, astronomers caught a gamma-ray burst that shouldn't exist, or at least one that half their telescopes missed. Dubbed the Phantom Burst, this violent flash of high-energy photons lit up sensors on the Fermi Gamma-Ray Space Telescope for a fleeting 2 seconds, vanishing before other observatories could pivot to witness it. Gamma-ray bursts are typically universe-shaking events, visible across billions of light-years. So how could one of the most advanced detector arrays in history catch a scream the rest of the cosmos seemingly ignored? The first explanation points to a cosmic fluke, a beam of energy so tightly focused it bypassed most of Earth's observational net. Think of a lighthouse sweeping its beam across the ocean, only a ship directly in its path sees the light. If the burst's relativistic jet was narrower than usual, perhaps due to an unusually stable progenitor star's collapse, it might have channeled its fury into a pencil-thin beam aimed straight at Fermi. Supporting this, the burst's light curve lacked the telltale afterglow that typically lingers when wider jets interact with interstellar gas, as if the photons raced by too quickly to leave a trace. Yet instrumental error can't be ruled out. Space telescopes endure constant bombardment by cosmic rays and solar particles, occasionally triggering false positives. Fermi's team ran months of diagnostics, checking for corrupted memory or sensor noise, but found no smoking gun. The burst signal bore all the hallmarks of a genuine astrophysical event, just one that refused to repeat or leave corroborating evidence. It's like hearing a gunshot in a crowded room where nobody else reacts. Either your ears deceived you or you alone witnessed something extraordinary. The most tantalizing possibility, a new breed of burst-defying classification. Most GRBs stem from collapsing massive stars or merging neutron stars, but simulations suggest a third option. A failed collapsar, where a dying star's core teeters on the brink of black hole formation before rebounding. Such an event might produce a stuttering, asymmetrical jet, one powerful enough to gamma-ray telescopes briefly, but too fractured to sustain a full multi-wavelength spectacle. The Whirlpool's turbulent magnetic fields could have further sculpted the jet, twisting it into a fleeting spotlight visible from only one angle in the cosmos. For now, the phantom burst lingers in astronomical limbo, a ghost in the data that challenges our assumptions about how stars die and how energy travels through the void. Whether it was a cosmic mirage, a telescope's fleeting hiccup, or a glimpse into an entirely new astrophysical phenomenon, its legacy endures, a reminder that even our best instruments sometimes catch only fragments of the universe's grand performance. Tucked away in a quiet corner of the Whirlpool Galaxy, a red dwarf star refuses to fade into cosmic obscurity, burning with the stubborn vitality of a celestial phoenix. Catalogued as M51 RD114, This ancient star should have settled into a sedate, cooling phase billions of years ago, its nuclear furnace sputtering as its hydrogen fuel dwindled. Yet observations reveal a paradox. Spectral lines shimmer with the energetic fingerprints of a star half its presumed age, its surface churning with magnetic activity and flares far too vigorous for a star of its vintage. How does a stellar senior citizen maintain such youthful vigor? The answer might lie in a cosmic fountain of youth or a case of mistaken identity written in starlight. One compelling theory paints a picture of stellar vampirism. Red dwarfs often orbit in binary systems, and if M51 RD114 has a close but unseen companion, a white dwarf or neutron star, it could be siphoning fresh hydrogen from its neighbor's stellar winds or accretion disk. Imagine an elderly athlete sustained by regular blood transfusions. Each stolen infusion of fuel might reignite the dwarf's core, temporarily staving off its inevitable cooling. Supporting this, X-ray telescopes have detected faint but persistent emissions near the star, a possible tracer of hidden interactions with a dense partner. Yet no companion has been directly observed, leaving astronomers to wonder, is the thief simply too dim or is something else at play? The alternative explanation flips the script entirely. Perhaps M51 RD114 isn't ancient at all. Stellar age estimates rely heavily on metallicity, the abundance of elements heavier than hydrogen and helium, as older stars formed when the universe lacked these forged materials. But the Whirlpool's chaotic merger history could have scattered metal-rich debris into later generations of stars, artificially inflating their apparent ages. If this red dwarf formed from gas polluted by a nearby supernova or galactic collision, its high metal content might have tricked us into labeling it a relic when it's merely middle-aged. It's like carbon dating a tree only to realize its roots were nourished by soil contaminated with ancient coal. Then there's the wildcard stellar collisions. While rare in the sparse outskirts of galaxies, the Whirlpool's gravitational dance with NGC 5195 could have hurled stars into improbable mergers billions of years ago. If two aging red dwarfs once collided, their combined hydrogen reserves might have reignited fusion in a spectacular second act, reset the clock on their evolution. Simulations show such events could produce blue straggler equivalents for low-mass stars outliers that burn hotter and longer than their peers. The absence of nearby stellar wreckage casts doubt on this scenario, but the Whirlpool's tides are adept at sweeping away evidence over cosmic time. The implications ripple far beyond this one star. If accretion or collisions can rejuvenate red dwarfs routinely, our galaxy might harbor countless immortal stars quietly cheating death in the shadows. Alternatively, if age-dating methods are systematically flawed in metal-rich environments, entire galactic timelines might need recalibrating. For now, M51 RD114 burns on, a flickering enigma that challenges whether stars ever truly grow old or if the cosmos simply holds more loopholes than we've yet imagined. Drifting through the outer fringes of the Whirlpool Galaxy, a glittering celestial parade defies expectations, not the usual dusty comets with their ghostly tails, but a radiant swarm of icy wanderers whose crystalline structures refract sunlight into dazzling cosmic prisms. These crystal comets don't just streak through space, they shimmer, their tails splitting starlight into spectral rainbows like diamonds scattered across black velvet. What could possibly forge such exquisite cosmic gemstones on this scale? The answer might lie in the violent death of an icy giant, a Pluto-sized world torn apart and scattered across the void. Imagine a distant, frozen planet orbiting a star in the Whirlpool's halo. Over eons, gravitational nudges from passing stars or the galaxy's own tidal forces stretch its orbit until, catastrophically, it swings too close to its sun. The star's heat cracks the world's icy mantle like a hammer to glass, shattering it into countless fragments. But here's where physics gets poetic. As these icy shards are flung into space, they don't just become ordinary comets. Their water molecules, once compressed under planetary pressures, reorganize into perfect crystalline lattices under the sudden vacuum of space. It's the cosmic equivalent of tempered glass rapid cooling, creating a structure both fragile and spectacular. Yet there's another, more explosive origin story. Some of these comets bear isotopic signatures hinting at a stellar interloper's role. Spectroscopy reveals traces of rare metals like iridium and platinum woven into their ice elements typically forged in supernova. This suggests the swarm might be debris from a close encounter with a rogue star or neutron star, whose gravity shredded an icy moon or dwarf planet while bathing the fragments in heavy element fallout. Picture a stellar bulldozer plowing through a glacier, its wake glittering with frost laced with stardust. The real magic, though, unfolds when these comets near the whirlpool's inner warmth. As sunlight heats them, their crystalline structures don't vaporize evenly like typical ices. Instead, they sublimate in geometric patterns, creating tail structures that fracture light like natural diffraction gratings. Telescopes have caught some displaying halo flares, rings of colored light around their nuclei, while others spark intermittent flashes, as if microscopic facets within their bodies act as celestial disco balls. What makes this swarm truly extraordinary isn't just its beauty, it's its defiance of time. Most comets shed their glory after a few close passes to a star, but these crystalline relics seem to persist. Their robust structures resist complete disintegration, turning each orbit into a recurring light show. Some researchers speculate they might even carry seeds of their progenitors' chemistry, pockets of primordial gas or organic molecules trapped in their latticework, preserved like insects in amber from a lost world. In the whirlpool's grand tapestry, this glittering diaspora is more than debris. It's a fossil record of destruction and rebirth. Every rainbow-hued tale tells a story of cataclysm and resilience, proving that even in the cold depths of space, violence can give rise to fleeting, impossible beauty. Deep in the Whirlpool Galaxy's western spiral arm, something invisible bends the rules of gravity itself. A region where stars and gas clouds orbit faster than they should, as if tugged by an unseen hand. Astronomers call it the gravity well anomaly, a pocket of space where Newton's laws seem to fray at the edges, and celestial objects move with the urgency of marbles circling a hidden drain. The first clue emerged when tracking the orbits of young, blue stars near the arm's outer edge. Their velocities suggested the presence of a mass equivalent to 20,000 suns, yet telescopes found nothing but empty space. No black hole, no dense star cluster, just a gravitational signature without a source. One explanation points to dark matter clumping in ways we've never seen. Simulations predict that this mysterious substance should form intricate webs throughout galaxies, but the whirlpool's anomaly appears too compact, too sharply defined. It's as if someone took a single thread of the cosmic web and knotted it into a gravity amplifier. Some theorists speculate this could be a dark matter droplet, a relic from the galaxy's violent formation, where primordial dark matter cooled and condensed into a super-dense blob. Picture an iceberg floating in an ocean, its mass hidden beneath the surface, except here the water is ordinary space, and the iceberg is entirely invisible. Yet there's a tantalizing alternative. What if gravity itself behaves differently here? Modified Newtonian dynamics, or MUND, proposes that on galactic scales, gravity doesn't weaken as quickly as classical physics predicts. Most evidence for MUND comes from galaxy outskirts, but the whirlpool's anomaly sits squarely in its crowded disk, a place where standard gravity should dominate. If MUND somehow flexes its influence here, it would upend decades of astrophysical models. Observers have noted subtle distortions in the anomaly's magnetic fields, patterns that align suspiciously with certain MUND predictions. It's like finding a fingerprint at a crime scene that matches no known suspect. The plot thickens with the anomaly's thermal footprint. While dark matter shouldn't interact with light, this region emits faint, uneven microwave pulsations that don't match any known astrophysical source. Some researchers suggest decaying actions, hypothetical dark matter particles, could be releasing this energy as they vanish. Others propose a more radical idea, quantum foam. At microscopic scales, spacetime is thought to bubble with fleeting particles and voids. If these quantum fluctuations became frozen here by some unknown process, their collective mass might warp gravity locally, like a wrinkle in the cosmic fabric pressed permanently into place. What makes the gravity well anomaly so enthralling isn't just its defiance of explanation, it's the way it mirrors mysteries closer to home. Our own Milky Way hosts similar gravitational puzzles like the Sigma Orionis overdensity, where stars orbit inexplicably fast. By studying the Whirlpool's version, we might crack a code that spans the cosmos. Until then, this invisible well remains a gravitational siren song, luring us toward answers that lie just beyond the event horizon of our understanding. In the Whirlpool Galaxy's starry tapestry, there's a nebula that plays tricks on the eyes not by glowing but by disappearing. Dubbed the Ethereal Nebula, this cosmic ghost vanishes when viewed through certain telescopes, flickering in and out of existence depending on the wavelength of light used to observe it. Unlike typical dark nebulae that simply block starlight, this one exhibits something far stranger: selective invisibility. Point an optical telescope its way, and you'll see a looming shadow against the galaxy's backdrop. Switch to infrared, though, and the shadow dissolves as if someone flipped a cosmic light switch. What kind of interstellar sorcery could make a cloud of gas and dust vanish without a trace? The answer might lie in the nebula's dust grains, their size, shape, or even their chemical makeup. Most cosmic dust particles are irregular, scattering light in all directions like pebbles tossed into a pond. But if the ethereal nebula's grains are unusually spherical or aligned by magnetic fields, they could behave like microscopic lenses, bending light around them rather than absorbing it. Picture sunlight passing through a frosted shower door. The glass diffuses the light evenly, making it seem to glow without casting sharp shadows. Similarly, these designer dust grains might be redirecting infrared light so seamlessly that the nebula becomes transparent, while still blocking visible wavelengths like a cosmic curtain. Yet there's a twist. Polarization data reveals the nebula's dust isn't just odd, it's organized. When astronomers measured the alignment of light waves passing through, they found a stunning degree of uniformity, as if the particles had been combed into parallel lines by some unseen force. Galactic magnetic fields could explain this, but the scale is unprecedented. Typically, such order is seen near energetic sources like pulsars or black holes, where magnetic fields are intense enough to dictate dust's behavior. The ethereal nebula, though, floats in relative quiet, far from any obvious power source. This has led to wilder theories like quantum-linked dust grains particles whose orientations are entangled across vast distances, creating a synchronized light filtering effect. Then there's the composition angle. Spectroscopy hints at exotic ices coating the dust mixtures of methane, ammonia, and organic molecules frozen into glassy layers. These ices could be acting like wavelength-specific mirrors, reflecting infrared light while absorbing visible. It's the difference between wearing a black shirt in sunlight. It heats up by absorbing energy versus a mirrored suit that reflects the heat away. If the nebula's ices are just the right thickness, they might cancel out specific wavelengths through interference, rendering the cloud invisible to certain instruments. The most mesmerizing possibility: we're witnessing a cosmic illusion, a nebula that isn't a single structure at all, but a projection. Some researchers speculate the shadow could be a light echo from a long-dead star, its final flash still bouncing off distant dust walls in a way that creates the illusion of a persistent shape. Like a magician's trick with smoke and mirrors, the ethereal nebula might be less a physical object and more a play of light and time. its disappearance an artifact of our limited vantage point. Whatever the truth, this phantom of the whirlpool challenges our assumptions about how matter and light interact in the void. It's a reminder that even the darkest corners of space can hide the most luminous mysteries, not by what they reveal, but by what they refuse to show. Somewhere in the Whirlpool Galaxy's spiral arms, a split-second scream of gamma rays pierced the darkness, then vanished without a trace. This wasn't just another gamma ray burst, it was a cosmic flashbulb pop with no photograph left behind. Astronomers call it the orphan flash, a burst of high-energy photons so brief it barely registered, yet so perplexing it's rewritten the playbook on how energy erupts across the cosmos. Unlike typical gamma-ray bursts, which paint the sky with lingering afterglows in X-rays or radio waves, this one left nothing. No fading ember, no smoldering debris field, just a blip of light and an echoing question. What kind of catastrophe leaves no wreckage? The leading suspect, a naked black hole birth. Most black holes form with fanfare supernovas that rock entire galaxies with their brilliance. But theoretical models suggest some massive stars might collapse silently, their cores imploding straight into black holes without the customary stellar explosion. Picture a sinking ship that vanishes beneath the waves without so much as a ripple, no lifeboats, no flotsam, just a quiet descent into darkness. In this scenario, the orphan flash could be the last gasp of a star's outer layers as they're swallowed by the newborn singularity, a flicker of radiation before the event horizon seals shut. Supporting this, the burst's energy profile matches predictions for such a failed supernova, with gamma rays emanating from plasma torn apart just outside the point of no return. Yet there's an even wilder contender, cosmic strings snapping. These hypothetical space-time defects, thinner than an atom but stretching across galaxies, are relics of the universe's infancy. If one snapped, releasing pent-up energy like a rubber band stretched too far, it could theoretically emit a gamma-ray flash without any accompanying debris or afterglow. The burst's razor-thin duration and pure gamma signature align eerily with what physicists expect from such an event. It's the cosmic equivalent of a glass shattering in an empty room. The sound echoes, but there's nothing left to prove it happened. The plot thickens with the burst's location. Most gamma-ray sources cluster in active star-forming regions, but the orphan flash erupted in a galactic backwater, a quiet stretch of the whirlpool's disk with no recent supernova, neutron stars, or other obvious triggers. This isolation fuels speculation about rogue actors. Perhaps a primordial black hole born in the early universe finally consumed a passing gas cloud. Or a neutron star colliding with an invisible quark star, their merger emitting energy in a wavelength we barely understand. What makes this flicker so revolutionary isn't just its mystery, it's the challenge it poses to our detectors. Modern telescopes are built to chase afterglows, to triangulate bursts using their multi-wavelength echoes. A flash that vanishes without a trace, it's like trying to investigate a crime scene where the bullet leaves no wound. If such orphans are common, we might be missing entire chapters of the universe's most violent events, quiet cataclysms that flare and fade before we even think to look. For now, the orphan flash remains a ghost in the data, a whisper of something vast happening in the dark. Whether it's a black hole's silent birth, a space-time defect's death throes, or something beyond our current physics, one thing's clear: the Whirlpool Galaxy keeps a ledger of violence even its stars can't fully reveal. And sometimes the loudest mysteries are the ones that leave no echo at all. Amid the Whirlpool Galaxy's swirling arms, an ethereal glow pulses where none should exist, a network of dust clouds shining with the soft, rhythmic light of fireflies on a summer night. This isn't the usual stellar fluorescence or the reflected glitter of nearby stars. These clouds emit their own eerie radiance, flickering in hues of emerald and sapphire, as if infused with some cosmic counterpart to bioluminescence. What could possibly make inert grains of silicon and carbon burn with such living color? the answer might rewrite our understanding of how interstellar matter interacts with the void. At first glance, the phenomenon mirrors Earth's oceanic bioluminescence, where organisms like dinoflagellates convert chemical energy into light. But in the vacuum of space, there are no living cells to spark such displays, only cold, abiotic particles. The leading theory points to a process called radioluminescence, where dust grains soaked in ambient radiation from nearby stars or cosmic rays re-emit that energy as visible light. Imagine sprinkling powdered glass onto a radioactive source and watching it glow. Except here, the glass is interstellar dust, and the energy comes from the whirlpool's churning heart. Spectroscopic analysis reveals tantalizing clues. Certain patches of these clouds contain unusual isotopes of magnesium and aluminum, elements known to phosphoresce under ionizing radiation when trapped in mineral matrices. Yet there's a twist. Some of the brightest clouds hover far from obvious energy sources, their luminosity undimmed by distance. This has researchers probing deeper, considering exotic chemistry at play. Laboratory experiments with analog space dust have shown that certain carbon-based molecules, polycyclic aromatic hydrocarbons, can enter metastable states when exposed to ultraviolet light, slowly releasing that energy as ghostly afterglows over centuries. If the whirlpool's dust is laced with similar compounds, it might function like a cosmic battery, absorbing radiation during periods of stellar activity and discharging it gradually, creating those mesmerizing pulses. Then comes the wild card, quantum confinement. Some of the dust's tiniest particles, nanoscale flecks smaller than a virus, could be exploiting quantum mechanical quirks to emit light. When materials shrink to these dimensions, their electrons behave differently, jumping between energy levels in ways that produce vivid colors. It's the same physics that give gold nanoparticles their ruby hue or quantum dots their electric glow. If the whirlpool's clouds are rich in such nanograins, their collective shimmer might resemble the synchronized flash of a deep-sea jellyfish colony. The most haunting detail, though, is the rhythm. Unlike predictable radiative processes, these clouds brighten and dim in irregular cycles, sometimes in sync with passing shockwaves from supernovas, other times with no discernible trigger. A handful of theorists whisper about dust organisms, not alive in any traditional sense but complex enough to exhibit emergent behaviors, their structures self-organizing in response to galactic tides or magnetic fields. It's a stretch, but not impossible. After all, complexity arises everywhere from hurricanes to neural networks. For now, these luminous clouds drift through the whirlpool like celestial will-o'-the-wisps, their glow a cipher waiting to be decoded. Whether they're cosmic chemical clocks, quantum oddities, or something beyond our current frameworks, one thing's certain. In a galaxy already brimming with wonders, even the dust refuses to be ordinary. And every flicker is a reminder sometimes the universe's quietest corners shine the brightest. The Whirlpool Galaxy holds one last secret, one so quiet it barely murmurs against the cosmos. Hidden within its swirling arms, dark matter isn't behaving as it should. Instead of spreading smoothly like an invisible fog, it's clumping into dense knots and filaments, twisting through space in patterns that defy every supercomputer simulation. These aren't just minor discrepancies, they're cosmic anomalies suggesting dark matter might interact with itself in ways we've never imagined. Take the galaxy's outer halo, for instance. In most galaxies, dark matter forms a roughly spherical cocoon, thinning out gently with distance. But the whirlpool's halo is lumpy, patches of extreme density scattered like breadcrumbs, their gravitational pull warping the paths of nearby stars. Some regions appear almost hollow, as if dark matter has pooled elsewhere, leaving behind voids that shouldn't exist. It's as if someone stirred the galaxy's hidden scaffold with a spoon, creating pockets of concentrated gravity where none should be. Theories abound, but one stands out: self-interacting dark matter. Most models assume dark matter particles pass through each other like ghosts, their only influence being gravity. But what if they occasionally collide or scatter like billiard balls in the void? Simulations of such interactions show striking similarities to the Whirlpool's clumpy structure. Dark matter blobs forming where particles have slowed each other down while other regions stretch thin. Picture a crowd of people in a pitch-black room. If they never touch, they'll spread evenly. But if they can bump shoulders, they'll clump into clusters, leaving empty spaces between. Yet there's a problem. If dark matter interacts this strongly, why don't all galaxies show similar lumpiness? The Whirlpool's turbulent history might hold the key. Its gravitational dance with NGC 5195 could have stirred the dark matter like cream in coffee, amplifying any inherent stickiness. Or perhaps the galaxy sits at a cosmic crossroads where filaments of dark matter from the larger web converge, piling up like leaves in a gutter. The most tantalizing clue comes from the galaxy's star streams, ribbons of stars ripped from smaller galaxies and stretched into long arcs. These streams should follow smooth, predictable orbits, but some kink abruptly, as if yanked by invisible hands. The positions of these kinks align eerily with the proposed dark matter clumps, suggesting an unseen tug of war. It's like watching marionette strings jerk unpredictably, hinting at the puppeteer's hidden movements. What makes this whisper so revolutionary isn't just the anomaly, it's the questions it forces us to ask. Is dark matter more complex than we thought? Are we seeing the fingerprints of an entire dark physics, playing by rules we've yet to uncover? The Whirlpool doesn't just hold these secrets close, it murmurs them in a language written in gravity and shadow. And with every strange clump, every unexplained warp, it invites us to listen closer. From supermassive black holes that refuse to play by the rules to rogue stars racing toward intergalactic exile, the Whirlpool Galaxy has proven itself a cosmic hall of mirrors, one where every certainty about how galaxies work gets twisted into something extraordinary. We've wandered through its ghost arms and dark matter labyrinths, stood baffled before blue black holes and zombie stars, traced the whispers of radio symphonies sung by magnetars. 50 anomalies, each a crack in the foundation of what we thought we knew. But here's the wildest part. These aren't just quirks, they're clues. Every time the Whirlpool defies expectations, whether with its crystalline comets or quantum-stepped starlight, it's handing us a piece of a puzzle we're only beginning to assemble. Galaxies aren't static paintings, they're living, breathing chaos engines, and M51 is their most flamboyant performer. It taunts us with questions. What if dark matter isn't silent? What if black holes have moods? What if dust itself holds secrets we've barely scratched? That's the real magic of space mysteries. They don't just fill textbooks, they ignite wonder. Maybe your favorite anomaly was the phantom gamma ray burst that vanished without a trace, or the twin nebulae that mirrored each other across light years. Whatever it is, drop it in the comments. I want to hear which cosmic head-scratcher hooked you hardest. And if you're hungry for more deep space enigmas, hit subscribe. The universe is crammed with whirlpools of its own, each one waiting to unravel the next chapter of Wait, That's Impossible. Until then, keep looking up. The weirdest stuff is still out there.